Hello, everyone. I hope you can hear me. Okay, great. Awesome. Good morning, everyone, or good afternoon or good evening, depending on where you're located. Welcome, everyone. And I'm happy to welcome you to this second Data Science Summer School organized by Hertie School Data Science Lab. And this year, Summer School is organized and funded by the Hertie School, and we're really grateful for this support and the fact that we can keep going with the second iteration of our summer school. We wanted to note that this year's summer school will begin with an introductory into programming classes and the mathematical foundations essentials that are essential for the success of the data scientists. And this part of the technical preparation is kind of a basis for the Master of Data Science for Public Policy program at the Hertie School. But as you can see, it's open for anyone interested and for the general public. So we're really happy to see you here today as part of this, basis kind of knowledge for that are important for the data scientists. And I'm extremely happy to see you all here on Zoom. And we also have a parallel stream session on the YouTube, and welcome to people on YouTube as well. And I would like to note a couple organizational and technical details just to kind of walk you through some rules. So people who are on YouTube, you're muted right now and you have your cameras off, and we will kindly ask you to not unmute yourself and not turn your camera on unless you have a question. If you do have a question, please leave this question in the chat. That way we can address the question as soon as possible. But if you really want to ask the question yourself, raise a hand, and then as soon as there's going to be a good moment, we will obviously give you a way to go, and you would be able to unmute yourself and ask a question. If you are on a YouTube, you can leave your questions in the live chat or in the YouTube comments, and we will address your questions and comments as well, either just typing the answer on the comments box, or we're gonna raise the question to the instructor so that everyone can hear your question. I should also remind everyone that this Zoom session is being recorded. And if you do unmute yourself and you do turn your camera on, you will automatically agreeing to your voice and your image being recorded. And I think that's pretty much it. Thank you so much in advance for following this organizational rules. And I'm extremely happy today to go on and continue with our second workshop in this series of events. And today we are having the introduction to programming in Python. And let me introduce you Dr. Tom Paschalis, who's going to be our instructor for today's workshop. Tom is a computational political scientist and a data scientist. He is an assistant professor in political science and data science in the Trinity College in Dublin. His methodological research interests include machine learning, Bayesian modeling, text analysis, record linkage, and data visualization. And without further ado, Tom, the floor is yours. You can share your screen and you can go ahead with the workshop, and good luck and have fun, everyone.
Thank you very much, Olga, for the introduction. This is really great, and thank you very much for inviting me to being here. This is a great opportunity to spread the Python gospel. I will later tell that I don't think I'm as much Catholic about the use of Python, and you'll see throughout the workshop that I will indeed use many examples and parallels with R, because I do use it and I actually do teach it a lot as well. So, and I use it on a daily basis, and I would just assume that some of you might already have some prior experience with other programming languages such as R or Stata. And this is indeed there is certainly no requirement, but for those of you who are familiar with, for example, it might be good to see some parallels. Let's jump in. Let me share my screen, and hopefully everything will work smoothly now. I have to apologize for the last minute changing the time. It really so happened that I was supposed to arrive to Dublin, back to Dublin yesterday, but unfortunately for the reasons related to the functioning of certain airline in the United States, it didn't happen on time, so it only happened today. We will. You'll see later when we go into the data analysis part. I spent fruitfully my day stuck in the US yesterday collecting some flight statistics data, and you will have an opportunity to also look at that, and maybe some of that will be helpful for you, not to anticipate and predict. We won't go about machine learning, but some of the data might be helpful for planning and prediction. So yeah, I do apologize for this change of time. Hopefully everybody who wanted to make it made it, and otherwise I believe the recording will be available. Okay, let's jump in, and I will assume, unless I'm monitoring the chat as well, so unless there are any screams in the audience or any screams in the chat, I will just assume that it works well and everybody can see the screen. Okay, before let's start from the very beginning. Why are we all here, right? So we're here to talk about Python. And just before this will be a programming class, so in case you are interested in reptiles, I do have to say a little bit about reptiles. I'll show you a Python symbol, which does resemble a snake these days. Originally, though, it was coming from the name comes from Monty Python, great British comedian show. From the 1970s and 80s. If you're really into British humor, I highly recommend it. We'll briefly touch on that because the name of Python actually comes from that. However, here we are primarily not talking about reptiles or the British humor. Here we're talking about what has become, and I'll show you in a few slides, that dominant programming language across all the domains, right? So Python has indeed become the versatile, multifunctional language that is used across the board. With that in mind, so here within this XKCD of comics, people are learning to fly using Python by just importing certain modules. I will say that in this specific module that I'm teaching today, I will focus more on the data analysis part because we, as part of the data science summer school, I will focus more on this part, which is applicable to, the getting your hands dirty with some data wrangling, and which comes at the cost of omitting some things that some of you who potentially are more into software engineering, more into computer science, might find the more lax treatment of subject. We won't touch upon the object-oriented programming, like the complex system that is integral to the functioning of Python, and you will indeed be using it even by just importing modules, but we sort of won't be touching that as much. So this is just to say that if you came here with this, hopefully you'll expectations, hopefully you'll learn about the data science side, and I will provide the pointers for how to go about learning Python for different perspectives. Again, as I already said, there is a lot of discussion. I'm sure you saw a lot of those debates. You probably have been part of some of those debates. What is best to invest your time in learning, whether it's R, whether it's Python. I don't think anybody, some people certainly still invest a lot of time in learning Stata. I don't think that many people are trying to convince others that SPSS is a great investment. Excel is still definitely a thing that I think everybody should know, one at least at some level. But this is, broadly some fun way of, how different users of different languages perceive each other. I particularly like, what I particularly like is how the users of Python, how users of R look at Python. The jealous boyfriend meme. This is indeed, I think, a lot of what I have internally as well. What is the best tool for a certain job, whether it's R or Python. And indeed, sometimes you just start doing something in Python and you want to continue doing it in Python. For example, you collected the data using web scraping, using Selenium, and sometimes you started doing the data analysis in R, and then there would be some machine learning library that is only available in Python, and then you need to kind of switch back and forth. Here we will talk from the foundational things of the basic things about Python, all the way to some notion of how to go about data analysis in Python. A few words about me. Olga has already given a great introduction. So I'm assistant professor in political science and data science here in Trinity College Dublin. Previously, I did research at the Center for Social Media and Politics at New York University, and I did my PhD in social research methods back at London School of Economics. I'm broadly interested in political communication and social media. I'm also interested in the part of political economy on interest groups and how they communicate on social media, for example. And methodologically, I'm interested in text analysis, machine learning, record linkage, and all things data visualization. Some context for me, you can hit me on my Trinity email or the email provided on the syllabus. Feel free to check out my website. Indeed, some of the materials that I'll be using here is a very confined set of topics that, for example, I teach in the Introduction to Computer Programming here in our Applied Social Data Science program here at Trinity. So all the materials for that module, for example, are available online. You can browse through them, and they contain both more material on Python, less on data analysis side, more on software engineering and computer programming side, as well as the same for also, you can follow me on Twitter, or if you find something interesting there, I'm always looking for great new memes to put into my slides. In case after all this slide, I was just thinking, in case you're feeling that this has been quite a week, you're not alone. I'm certainly in with you this year, but I do have to remind you that unfortunately it's still Wednesday, so let's see how that way goes. Given the scale of how many of us are here, I don't think we can introduce everyone individually. So what I thought, or rather learned from another lecturer here at the Data Science Summer School, one thing we can do is head to this website that is provided here below, www.menti.com. If you enter that code, I should be able to and provide the answers to two simple questions of, let's see whether that works, about your background and about what's your, where you're coming from. This will provide us with some opportunity to see what everybody here is into. Let's see. We see a lot of people from political science and economics. This is great. Phonetics, area studies. amazing business, a musician. Wow, public policy and admin, new media, mechanical engineer. This is great, guys. Yeah, I really like how broadly dispersed your interests are. Yeah, the code is at the top here as well. 45, 25, 37, 63. Great, thank you, guys. Let's see astrophysics, because this is indeed a great tool, I have to say. Did I? Oh, I'm really sorry. I really didn't know about access to the restrictions on access to Menti from Russia. Yeah, I feel like if you cannot access Menti, feel free to just introduce yourself in the chat. Really, like I think it will work perfectly as well. VPN might genuinely work, but some things can take some time to set up. China, Germany, Berlin, Egypt, Russia, Romania, Armenia, Sweden, whoa, Czech Republic, Leeds, Florence. Guys, we're like everywhere. France. This is really cool. I hope this provide a bit of engagement for all of us, and a possibility to introduce ourselves. This actually works pretty decently, I have to say. And one never stops learning new things. I just discovered about that not so long ago, about this tool not so long ago. Let's go back. Let's go back to our slides, and I think everybody can probably see the actual presentation if they head to the website. I'll try to save it and somehow put it inside the slide deck, because so far I haven't actually figured a way to have it as part of the regular slide. Okay, I don't think I need to do a lot of convincing you of why Python. Why not other language? Python is free and open source. You might say so is R. However, one thing, as I already said, Python is a truly versatile programming language, meaning you can write everything from integration with web protocols all the way to data science, which comes and I will we'll talk about it later on, which comes at a certain cost that a lot of things that we as data scientists, as social scientists, as statisticians might take for granted. For example, when working with R, takes a little bit of time to get used to when we're starting with data analysis with Python. Great library ecosystem. Another thing which comes up more and more often, especially in PhD training, Python is widely used in the industry. If you're joining a team and everybody on that team is a software engineer, chances are high that at least some of the people on that team would know Python. The same cannot be said about R, unfortunately, let alone more specialized social science statistical languages like Stata and SPSS. Which also means there is some pressure to actually learn Python even during the social science training these days. Popularity of programming languages. As I already said, this past June, this year, basically, as you can see, Python overtook C as the most popular programming language across the board, right? So not just for data science, but for any any other purpose, right? So it still used to be when I just started teaching some of the workshops last year in 2021. It was still the second. This year it actually is officially Python. Python is at the top. C++ is still heavily used for intentional computational intensive tasks. Unfortunately, Julia is not maybe taking off as fast as possible. I also heard there is a special version of C++ developed at Google, basically a new an enhanced version of C++, another C+++, I guess. Just learned about it from Twitter this morning. If you go to the actual source for this website, the TOB index, you will see that R is also there, but it's unfortunately in the second. It's about 15th. I think it takes about 15th place. Right. Carbon was developed. Yes. Thank you. Thank you very much for the for clarifying. Yeah, I completely blanked on what the name for the new C++ is. Popularity of specific tools to work in Python, and here's I'll have to say that we'll use Jupyter notebooks. In particular, we will be using online version of Jupyter notebooks. As you can see here, they are the most popular as per Kaggle State of Data Science and Machine Learning survey. I actually highly recommend looking both at that particular survey and the data associated with this survey. It's a really rich rich data on the patterns of data science professionals, and it's also a Kaggle competition in which you can win something like a few $1,000s, I believe. Jupyter Notebook comes to the top. If another alternative is Visual Studio with an addition, and I think Visual Studio, Visual Studio Code, if you're not using it even independently of Python, I think this is a great tool to be familiar with. It's a great text editor, just broadly multi-platform, cross-platform text editor, which is great for writing Markdown, writing LaTeX, writing Python, writing R. If you are, if you have something, against using RStudio, for example, or have other preferences. Two other things to mention. Spider in particular, if you are looking for the data analysis software which provides Python, which provides an ability to program in Python, but with the closest possible resemblance to RStudio, I highly recommend using a Spider. It's not as glossy and shiny as RStudio is for R, so it's not as feature rich. It does not have the backing up of a pretty substantial company by now, like RStudio. But it is it has all the general multi-pane setup that you would be used to with RStudio. I already said most of those things. I highly recommend having a good text editor, and I think today the best choice is really Visual Studio Code. But there are definitely alternatives such as Atom with Sublime Text. I highly recommend trying each of them out. Again, I highly recommend looking at Spider if you're looking for something like RStudio in Python, and PyCharm if you're more into CS and development. But here in this particular module, we'll stick to Python and Jupyter Notebook. Jupyter Notebook was developed originally as a Python as a Python interactive computational environment. It expanded to include both Julia and R. So these days you can use it with both Julia and R, and basically the name Jupyter was chosen to reflect that. I do have to say that most of the users of Jupyter Notebook still come predominantly from the Python community, even though it works seamlessly with R, for example. But I think in R it kind of comes as it can be seen as a competition with R Markdown. Can be used both locally and remotely, and good for ad hoc data analysis visualization. And again, if you're going to, if you're checking out Kaggle, for example, it has a lot of examples of Jupyter notebooks, especially the ones that might be worth looking at, are the ones that actually won some of the competitions. Notebooks basically allow writing, executing, and viewing the output of Python code within the same environment. They have the extension .ipynb. As you can see, the actual extension comes from the interactive Python notebook, even though they today can be used for both Python as well as Julia and R. The main unit of a notebook is cell, which can contain Python code, Markdown, or HTML. And then the output of a cell can include text, table, or figure. So for this workshop, if you want to follow along, I highly recommend going with the online platform. I recommend choosing either Google Colab or Kaggle Code. I personally will show everything in Kaggle Code. There are some neat features there that I like, and also I think it by virtue of not being tied to your Google account as much as Google Colab, even though technically Kaggle these days is also owned by Google. Alternatively, and I think this is either I would assume that you already have Jupyter Notebook installed, for example, through Anaconda, or I would recommend skipping this part, sticking to the online platform, and then doing it after the workshop, just because installing the local installation of both Python and Jupyter notebooks can be a little bit finicky depending on your machine. Feel free to look at the pip and conda, the two main ways of installing Jupyter notebooks. Unless you have prior experience, I highly recommend going with the Anaconda distribution, which contains all the packages required for this course. I'll probably skip the demonstration, and actually instead of this, let me maybe show you Kaggle code. So if you register, for example, in Kaggle, and you will see something like this. You can go and press New Notebook. And the link for Anaconda. So one thing maybe before, let me go here. So everything I show you today is available at the GitHub repository, this GitHub repository, which includes the link to Anaconda, and if you everything else that you see on the screen today. So it's just bit.ly/ds3-python. So if you go there, it will take you to this GitHub repository, which contains the lecture materials, the syllabus, the exercises, as well as the flights data that we will be using today, as well as some of the overview here. So this is so the slide. All the slides are in the lectures. So for the they live there as both HTML files and Jupyter notebooks. If you want to see just the rendering the way I see it, you can go here and then basically replace the last. So this is the current introduction. So if you for example, if you want the rendering for for the basics for the pandas and data HTML, just replace that link with the last part with the corresponding name of the file. VS Code, good question. I think generally, if you have installed the bindings for Python, I think generally should be fine if you have the libraries installed. In particular, pandas, and we'll look at plot9 for data visualization later as well. If you have basically those libraries installed, the specific libraries, if you want to know which libraries you need to install, this is the technical technically this, and I think you would actually won't even cover stat models. You only really need pandas plot9 libraries on your machine on top of, and whatever the dependencies they will install, as well as Jupyter. But if you're going with the VS Code, you really only need those two. So you can find if you have those installed, I think you should be fine with any editor, and not just without Jupyter Notebook as well. But I recommend going with the online editor if your internet connection allows. You can clone the repository. One thing I wanted to show you before we go into the Python code. So if you, for example, if you start a notebook on Kaggle code, you can do you can import a notebook, and specifically you can download, you naturally can download the notebook and then upload it on Kaggle. But the neat feature that I really like, since this is a public repository, if you do import from GitHub, you can just type in my name. Oops. Unfortunately, I cannot spell my name anymore. And then you can see DS actually pops up automatically for you, the name then of the repository, the branch, and then you can select the specific file. For example, you can if you want to look at the exercises, you can import the exercises, and then you are here, right? So you are ready to go and run the code. Pictures unfortunately would not render. So you can find the pictures either on the GitHub originally, or you can go with the rendering of the slides. But otherwise, this is the Python code. The first time you run a cell, it will take a little bit of time. So just be patient. But generally, I recommend going with the with Kaggle code and then importing individual Jupyter notebooks into your session and then working for them. The same goes for the lecture slides. You can import the entire lecture slide. So I think this has run now. If we end. Right, so this would work just if you have the internet connection without the need to go through the local installation. Right. Okay. The materials are there. Get ready. Okay, let me. So if you go file, import notebook. And then import from GitHub. Here you go with the repository, and then once you have the handle, oops. Takes some time to search, but generally that works. This, I don't think I misspelled. I misspelled the handle. Oops. Okay. Perfect. This is roughly the plan. We'll start with the introduction to Python objects and data types. This will be the first part. Then we'll have our first exercise. I'll give you about I strongly suspect, because we are so many people, that I think maybe searching for the same handle like legitimately overloads the. I truly think that we are kind of DDoSing it at some point. I think yeah. So I think try the handle. If the handle doesn't work, basically download on the local machine and then throw it up. I feel like we legitimately might be putting Kaggle under some load when we do that all together. If you do, so we'll start with introduction to Python objects and data types. We'll have an exercise, short break. Then we'll go with the introduction to pandas, exploratory data analysis and data visualization, and then we'll wrap up with another second short exercise. Some other pointers before we move on. Just this is a really introductory course. I will try to cover as much material as possible, as much novel material for those of you who are familiar with other with Python or with some other programming languages, say R. But I do want to provide some pointers for in terms of books in particular and some online resources that would allow you to develop your skills in using Python for data analysis further. I highly recommend the first two books in particular. Introduction to Computation and Programming Using Python by John Gottag, professor at MIT. It has been recently republished in its third edition. Great book. It also has an accompanying set of lectures that are available on YouTube. It's a fully fledged course. It's slightly more geared towards computer science majors, and especially I think the original has been done using Python 2. So some of the things are actually outdated, but the book is completely in Python, follows Python 3. Has been fully updated for Python 3. And Wes McKinney's Python for Data Analysis, the original author of Pandas library. Another book that I highly recommend. If you're generally looking, for ways to use Python in your daily job, this book, How to Automate pretty much random things that you might do with your computer, is another good start, and some online resources that you might want to check out. Python documentation. Specifically Python 3 documentation. Do note that sometimes if you Google for some function, you might still, especially going through Stack Overflow, end up looking at Python 2 documentation. So do make sure that you're always looking at Python 3 documentation. Python 2 is no longer maintained. A lot of answers on Stack Overflow would still refer to Python 2. However, it's best to go and double check what the contemporary documentation of Python 3 says on that particular issue, on that particular function. All right, let's move on. The presentation is available either on Github Repository, in the Github Repository, or it's available here rendered at my website as an HTML, or you can just download HTML and open it with your web browser. I think so far all the questions that I've seen have been answered. Let's move on, since we have quite a bit of material to cover here. All right. Let's dive in with some Python background. On the left, you can see Guido van Rossum, the original developer of Python back in the 1980s and 1990s. He got a position of benevolent dictator for life. You might think one way or another about whether this is a good place to be. However, he is no longer since 2018. But Python language and Python project is thriving, as you can see. Another note that I already said about Python 3, it was first released in 2008 and is the current major version. So, right, if you are using Python 2, or if you're coming across Python 2 code, some of it might be directly used in Python 3, but do make sure that this is actually true. Python 2 is no longer maintained. There is no longer support for more than 2 years now. So this is, but there is a lot of information out there which was designed for Python 2. Design of Python is a brilliant way to start as an alternative to print hello world. You can do import this, and it prints out the what is it to write good Python code. And a lot of it is very metaphysical, but reference to those metaphysics you will, and links to this metaphysics will come through the use of Python, throughout the use of Python. Where does Python stand vis-a-vis other programming languages, right? So Python is an interpreted language, just like R, just like Stata, if you used one of those two before. Every program is executed one command, one statement at a time, which, especially for the data science, means that our work can be done interactively, right? So we can still do print hello world. The conceptual hierarchy of Python. So we tend to think about programs. Programs can be rather complicated, right? So a video game is technically a program. It can be a web scraping script, which might also be thought as a program. Broadly, programs can be composed of one or more modules, right? So a module is either a Python library that you're loading, or it can be just a simple Python script, right? So ultimately, if you are just using a simple, if you're writing just a simple.py script, this already is essentially a module. Now, your program can consist only of this module or multiple modules, depending on how complex it is. Within modules, within your script, you can find statements that in turn contain expressions, and then expressions create and process individual objects, right? Everything that Python operates on is an object. It includes literally everything you can think of: numbers, strings, data structures, functions, etc., etc. Each object has a type and some internal data, right? Another thing to note about objects is that they can be mutable. And you will see with the basic Python objects, for example, lists, and immutable such as strings. Objects and operators are in turn combined to form expressions. Some of the key operators you would be familiar: some arithmetic operations, addition, subtraction, multiplication, Boolean, relational, assignment, as well as membership operation. Which should not be forgotten, and it also comes in handy very frequently. Basic mathematical operations. So, for example, if you want to add some numbers, you can just write 1 + 1, run that chunk of code in your notebook, and you'll get the results, right? So here I already have in the slides already did this pre-running of all the code. I will look specifically at the assignment operator later on, so we'll go over it. But just to note that you can copy paste that code and individual chunks, and I highly recommend following along me by running this this code in Jupyter Notebook, for example, on Kaggle or Google Colab or on your local machine. Subtraction, division. One thing to note about the division, that despite the fact that we are dealing with 2 integers, the result of the division actually comes out as a real number, right? So we actually have a float here, which we know by seeing that this actually is, we have a fractional part. We have 0.0 after, even though there is technically could be an integer, right? This is the result of the mathematical division in Python. Multiplication, exponentiation in Python is done with 2 stars. Technically, would also work in R like that, but in R, this syntax, while operational, is not recommended. Another note here: Python comments start with a hash sign. If you've been using other programming language like R, this would not come as a surprise to you. Otherwise, do know that everything that is commented out is not interpreted as Python code and thus is not executed. Basic logical operations, not equal, exclamation mark, and equal sign, results in true in the Boolean value of true. 3 more than 3 is greater than, is false, greater than or equal. Now, if we just write the word true or false with the first letter capitalized and the rest in the lowercase, those are interpreted by Python as Boolean values, right? So if we just write false, if we just write true, those are reserved words in Python and would be interpreted as such, right? For those of you coming from R, do note that it's not the full word which is capitalized, and also do note that we do not have Python does not have the shortcuts of capital T and capital F, right? This is something to keep in mind. This should not really be possible in R as well. It's quite annoying, but it is a possibility. There is no such possibility in Python. It's true and false with the first letter capitalized. You can combine 3 Boolean expressions together. So here, right, the first evaluates to false. The second evaluates to true. So right, essentially it is equivalent to the previous one. And since we're asking whether it's true, false or true, it is evaluated to true, right? So or statement is true if either first or second operand is true, or false otherwise. Somebody was already keen to learn, move forward and learn about assignment operations. So what is assignment operation, right? Assignment creates object references, right? So we have the actual object. For example, the integer 3 is an object. If we say x equals 3, we are binding the name x to the object 3, right? So we have a name. We're giving it a name. There is nothing specific about this name. You just pulled out of a hat. So this is important since equal sign here is an operator which gives us the possibility to do the assignment operation. Again, for those used to R, for example, R uses typically a more intuitive, visually more intuitive, but somewhat less common in computer programming symbol of greater, less than, and then followed by a dash. There is nothing like that in Python. The only assignment operator available is equal sign, right? Equal sign, single equal sign is the only assignment operator available. There is no left-hand side, right-hand side, all the complications involved with the assignment operator in R, which deserves several slides. Here it's just equal sign. If we then write x, we get the 3 back, right? We get the object that we referenced by this name back. Another trick is an increment assignment. So we can write x plus equal 2. You saw on the previous slides, there are different variations of this. There is minus equal sign. There is a multiplying equal sign. They're all essentially equivalent to putting the plus sign before the number on the right, and then adding to the original object, right? So in case here, the result of it is 5, right? So we added 2 to 3, and we saved the result of this in the same object, right? So we in the same with the same name. We've given it the same name x, and so we changed the name x from referring to the object of integer 3 to integer 5. Right. Important note to make assignment versus comparison operators, right? So you saw the comparison operator, double equal sign. They look very similar, right? It's just only the difference in how many equal signs you have. They can create confusion due to this, right? So we can, if we create x equals 3, but then if we check that x double equal signs 3, right? This is a logical operator. We're checking whether the object that x is referring to is actually an integer 3 or not, right? And in response, we get the Boolean value of true. Right. So this is something to keep in mind, that these are the two different sets of operators. Membership operation, pretty straightforward. In, just the word in, it is reserved. You should not be using it. So one thing about the reserved words is that you should not be using them for your for any variables that you create during your session, right? So you don't want to you don't want to try to do something like in equals 3, both because this results in an error, and because potentially if this had not resulted in an error, this would have provided some complications later on. So on top of the reserved words that automatically give you invalid syntax error, you might want to keep in mind the common functions, such as summation functions, summation function, etc., that are not necessarily reserved words, but would create confusion if you use them to refer to the object that you created during your session. Turning back to the membership operation, one neat thing about Python, especially vis-a-vis R, which might be the reason for why Python is so much more widely used in natural language processing, is the strings are more interesting structures in Python than they are in R. So, for example, here we have a string ABC, which is in quotation marks. We know this is a string. We can use the membership operation for an individual letter in that, for an individual character in that string, right? So it gives us back the Boolean value of true. The same goes for a list. We will talk about lists in a second. For now, lists are just sequences arranged within the square brackets, right? So we have 1, 2, 3 as a sequence, which is a list. We ask whether 4 is in that list. We get false as a result. If you've been using R, in is equivalent to in R, an equivalent function is in the percentage signs. So something that you can check, for example, whether an element exists within a given vector. Another which Python brings is that we can actually do for not in 1, 2, 3, as opposed to just having the in function or negating. We could have negated the entire expression the way we, for example, do it in R. Here we can just write in Python. We can just write not in. Python objects have scalar and non-scalar types, which again is somewhat different to the way you might be thinking about objects in R. Scalar objects are indivisible. You cannot modify any individual element of a scalar object. And four main types of scalar objects in Python are integer, real number, Boolean, and a null. You can check the type of an object in R by using the type function. So if you write a type function and you put a number in here, and it's just an integer, Python tells you that this is an int, meaning it's an integer. If you do it for a number which has a fractional part, for example, 0.14, this is a flotation point number. Right? So the same goes for the reserved word true. Python automatically recognizes this as a Boolean, and the same for the none type. I'm not sure exactly about the last question. We cannot. So the scalar is indivisible in a sense that you cannot modify each element of. There is no individual element within a scalar type that you can modify. The Boolean here is not a function. Boolean here is an object type, right? So Boolean is an object type which corresponds to either true or false, right? So it can only take two values, true and false, which only corresponds to which you can sometimes would be represented as ones or zeros, or you can think about as some flag, or you can think about as a binary variable. So if you think about a binary variable, some of them could be represented as a Boolean values. Yeah, exactly, binomial. You can cast different one type into another type. So, for example, you can by casting essentially means converting from one type to another. This comes at a cost. Potentially, some of the types can be converted into another without losing anything. So in practice, right, with the Boolean, for example, you can represent them with trues and falses. You can also represent them as ones and zeros, which underlines a lot of the all of the electronics, right? So this underlying of all of the computers, the fact that we have semiconductors and we represent them everything at the end is one and zero. So it is with the Boolean, right? So Boolean effectively can be represented as well by ones and zeros. With some types, as you would imagine, converting actually comes at the cost of losing some of the information, right? So for example, if you're trying to represent 3.14, a flotation point number with a fractional part, 0.14, as an integer, you would lose the fractional part. So you would lose the 0.14 here. So far so good with the scalar types, right? So those are also straightforward because since they do not have any more complicated internal structure, there is no individual sub elements that we might want to operate on. Non-scalar types, also known as sequences, have some internal structure, right? So which allows a lot more functionality that we can exploit dealing with this, right? So it allows indexing, it allows slicing, and a lot of more other interesting stuff that we can do with those. The most common in Python, the built-in ones that come when the base Python installation are strings, tuples, lists, sets, and dictionaries, right? So strings are immutable ordered sequences of characters, as you would imagine. Immutable meaning that individual character within a string cannot be modified, Tuples are immutable ordered sequences of any sort of elements, right? So it can be either characters or they can be any sort of numbers. Lists are mutable ordered sequences of elements. Sets are mutable unordered collections, right? So we cannot, within the sets, every element is unique, and we cannot also index them or refer to the first or the second element. And dictionaries are mutable unordered collections of key value pairs. So let's explore each of those one at a time. So just to give you an example of how they would look like, a string. String can be, a single word. It can be a sentence, like here. Tuple. By mutability means that we can modify individual element of a sequence, right? So we can within this list we can replace 0 with 10, and the list will be with us. Within this string, we cannot replace E with I, for example, or with any other character for that matter, as well as for this tuple here. We also cannot replace any of its elements, right? So the difference between the tuple and the list, as you can see here, is that we have round brackets vis-a-vis square brackets for lists. So the tuple is defined by the sequence within this round brackets. A list is defined by the square brackets. If you have curly braces, it can mean either it is a set. So, for example, here I have a set O, which is looks just like any other sequence, but all of the elements have to be unique. Now, if we create a set with non-unique elements, Python will just automatically delete remove any of the elements that are not unique within this set. For the dictionaries, you can see that they're still in curly braces, but what they also have are the key value pairs, where the key comes before the colon. So here, Apple is our key, and 150.0 is our value. The same for the banana, and the same for the watermelon. Right? We have 3 keys, and we have 3 values: 150.0, 120.0, and 3000. Dictionaries are. Do take note of the dictionaries, since they will form the basis of what is the data frame in Python, right? So when we'll talk about the data analysis in Python, and we'll talk about pandas, dictionaries basically will form what is the foundation of what would be a data frame in Python. The same as with scalar values, we can do with non-scalar types. We can check their type by using our type function. Type S equals string, type T equals tuple, type L equals list, type O equals set, right? And type D equals dictionary. Oops, as you can see. Indices and subsiding in Python. So, right, as I said, what distinguishes non-scalar types from scalar types is that we can subset individual elements from a sequence, right? So we can slice to extract subsequences of arbitrary lengths. For that, we can use square brackets, right, to provide the indices of the elements that we're interested in. So, for example, we have the name of the object, right? So we have the name of the object, and then we put in some indices that we would like to extract from. Indexing in Python starts from 0. If you are coming from computer science background, you might wonder why this is such a big deal. Most programming languages probably start indexing from 0. If you're coming from statistics background, or if you're coming from R background, this might strike you as an odd decision. And there is the reasons for that go back to the foundations of computation. If you're interested about those, I highly recommend reading both Why It Is the Case in Python, written by the original developer of Python, Github Repository, or why numbering generally should start at 0, which you might sound pretty extreme to me, to you, and then you might want to rate this post by a famous Dutch computer scientist who wrote a lot on algorithms and algorithmic computation, which is a broader topic that I don't want to go too much into at the moment. For the purposes of today, just keep in mind that indexing in Python starts from 0, right? So meaning that the very first element has the index of 0, the second element has the index of 1, the third element has the index of 2, and so on and so forth. Why indexing is important? Indexing comes a lot in computer science. The first response probably would be, people obsessed about sorting and sorting algorithms, and this is the quintessential example in algorithms. If you think about data analysis, you can think about how to subset the columns. And you can subset the columns by name, but sometimes you read in, there's got some CSV file, some data file you read in. It's pretty messy. It has a ton of columns that don't actually have meaningful names at all, and you would just want to refer to remove the first 6 rows, the first 6 columns, etc., etc. In order to do that, you would need to refer to those columns or to those rows somehow, which brings in the index and its slicing, right? So you would need to subset the indices, the elements from the column from your table that you would like to remove from them, right? So this comes a lot in data science and data analysis for slightly different reasons than it comes in core computer science. Let's look at some of those types one at a time. Our string, time flies like a banana, it has the length of a string. To get the length of a string, we can use the function length. If you've been using R, for example, it is essentially equivalent to length function. Here it tells us what is the length of the string, which includes white spaces, right? So there is no fancy tokenization. There is nothing, separation by words or anything like that. It's just the number of characters, including white spaces, right? So 24 is just the length of that string. We can subset the first element, right? So we cannot modify the elements of that string. We can still look at them and we can subset them, right? So we can. So for example, we subset the first element, which is the letter T, the character T. Indexing starts with 0, so we do the 0 here within the square brackets. You remember the first. If you want the first element, it's always 0. We can do more fancy slicing. We can subset of elements starting from the 6th, for example. We have in order to do that, right? We don't write 6 since we need to make the adjustment for the for this offset. So we have all spaces also count in strings. So we have, if we want all the elements starting from the 6th, we write 5 column, right? So here we don't need to define what is the end of it. We just say Python does it automatically for us. It goes all the way to the end of that string. Another interesting feature that comes in handy very often is that strings can be concatenated together, right? So we cannot replace an individual element of a string, but we can bind them together, right? So for example, if we want to add an exclamation mark at the end of the string, we can just write plus and give another string which contains 1 character exclamation, and we have our string back. One thing to note here, right? We have not actually modified the original string. All of those, right? The original string is still S. Since there is no assignment operator anywhere on this page, we still can refer to as, and as is still refers to the object, to this object, right? So if we want to actually replace as, so for example, if we want this to be our new as, we would need to use the assignment operator. We would need to, we would need to write as plus exclamation mark, as equals plus exclamation mark, right? So that's something to note if you think that actually something happened to us. The results were printed out automatically within this cell, the computational cell in Jupyter Notebook, but nothing actually happened to the underlying string per se. Objects have methods. So one thing we already saw are the application of functions, right? We saw the type function, we saw the len function. Methods, however, functions, if you're used to R, functions would basically encompass everything. In Python, things are slightly more involved. Functions are typically used for very broad tasks, right? So, for example, extraction of length for things of calculating what is the type of the object, very basic foundational things. For anything more sophisticated than that, for anything more targeted, more tied to a specific type, we have methods. It goes to the object-oriented type, object-oriented nature of Python, and the object-oriented programming, which I don't have quite enough time to delve into. For the purposes of this introduction, one thing to remember is how they look differently syntactically, right? So when we saw the application of a function, we just have the name of the function and then the object within the brackets that is applied to. When we're dealing with the method comes after a dot, right? So we have the object name, then the dot, and then the method that we apply to to that object. Or if our object is, for example, a module, the method will be a method coming from that module. We'll see it with the pandas and the reading in of the data sets, for example. So this is the function len s equals 24. If we want to uppercase the entirety of our string, we can write s.upper. Upper here is the method, and it makes our string uppercase. With most of the methods do not modify the object in place. So here again, s is still unmodified since we did not reassign it. However, with some of them, such as lists, things can get a little bit dicey. Like some of the methods applied to list may actually modify the original list. However, for most cases, we would still need to use the assignment operator if we want to go back to if we want to actually make the changes to the original object. Some of the string methods, just really quickly to look over them. Capitalization as capitalize, if we want to get the first character as opposed to all of the characters within the string to be in the uppercase. We can do some primitive tokenization, right? So we can do some primitive splitting into separate words, where we have s.split, where split is our method, and we're providing an argument sap equals white space. We're splitting by the equal space, so the Python finds for us that everything between the white spaces is treated as a word, right? What we get back is a list, right? So this is a list as we've seen before, by virtue of it having the round brackets. We can also replace some elements of the list. We can do it with as replace. For some of the more sophisticated, you probably would want to look at regular expressions, which will be covered in the text in the text analysis class. One other thing to mention is joining, since it's relatively common and maybe not very intuitive. We're joining if we want to join back this list, So, right, we tokenize the split into individual words. If we want to reverse that operation to go back to the original string, we can do join. Here, if we want to just get the original, we can do white space instead of -u dot join, and then here we have the that list provided. Right, again, we have never saved any of those outputs. Those outputs are still just printed out. They're not saved. So here we're providing that list to that method.join. And it is applied to the object dash in this particular case. It could have been applied to white space, but here we're joining it back, and we get those dashes in between individual words. Tuples can moving on from strings to another immutable sequence. Tuples can contain elements of different types. So they don't have to be individual characters. They can be anything. Here we have a mixture of integers and strings. The length here is the length of those, the length of the elements. The elements between the commas. How many elements are separated by commas? We can still do the indexing or slicing. It works the same way. We can do T if we want to all the elements starting from the second. We do 1 colon. We get all of the elements back. Like strings, tuples can be concatenated. You might wonder why we care about tuples. Like, why cannot we just use lists all the time? One thing about tuples come from the language itself, the term itself, tuples, comes from working with the databases. So in databases, we really want to keep things as fixed as possible. If we get a row from a database, we really don't want to, make some modifications to that row by removing some of the elements, for example, by shortening that tuple and proceeding to insert it back into our database. So it really has to do a lot with the database infrastructure that tuples are designed to work with. So if it strikes you as rather inflexible vis-a-vis the lists, don't be puzzled. This is their primary target, but they do come helpful in cases where we actually really want to restrict the modification of an object. If you have a list that you would want to restrict, you want to restrict it to and do not allow the object to be modified. That's right. For indexing in tuples, we use square brackets. We use square brackets for indexing everything, as opposed to the parentheses in which the the definition of the actual object is, right? So the actual tuple is a sequence within the parentheses, but once we move on to indexing, the indexing always happens, like the indexing operation always happens within square brackets, right? So it applies to both tuple, list, string, all the way to the data frames, which we'll see later on. So let's another structure, which now is another sequence, which is mutable now. Like tuples, lists can contain elements of different types. Unlike tuple, lists are mutable. So this is an operation that we could not have done using a tuple. We can write L and then modify the second element from the string 1 to integer 1, right? So now our L is modified. So right, since we use the assignment operator here, since we use the equal sign as an assignment operator, now our L is actually modified. So we modified the second element as opposed to a tuple, right? So if you try to do that with a tuple, if you try to modify the second element of a tuple, very verbosely, our Python just tells you that it's a type error. Tuple object does not support item assignment. Right. So this is we cannot do that with tuple. Indexing and slicing lists, it comes very often, and I guess lists are the probably one of the most common sequences in Python. So again, we can subset all elements starting from the second. We can subset just the last element. So note here that as opposed to R, where if you do something like -1 within as an index to a vector, it gives you the original vector back within the very last element. Here in Python, this gives you back all the only the last element, as opposed to all of the elements without the last. Indexing and slicing has a more general structure. Essentially, the syntax for it is the object, the list, for example, the start. So right, we have defined the start. We have omitted the stop and the step, and are just in Python. I keep saying R instead of Python. I hope really nobody believes that this is supposed to be an R class, and I think but hopefully for some of you who are coming from R background, some of those parallels make sense and are actually helpful, because otherwise I should probably stop making those parallels. But I really hope that for some of you, if you're trying, if you've been using or learning R, some of those things might raise the point in the intuition behind. Okay, great. Yeah, thank you. This is so. Start, stop, steps, syntax, for example, might be familiar with you. For some of you who, if you use like sec function in R, here it only comes. It doesn't have an actual function, right? So it comes within the general indexing framework. So we have the start, the stop, the step. So the stop assumes to be the last element if we don't specify it specifically. The step is also 1 unless we actually specify it explicitly. So for example, here we have L09112. If we want every second element starting from the first, we can omit both the start and the stop. The start is assumed to be the first element, the 0th element, so to say. The stop is the last element, and the step here would be 2, right? So we specify the step after the column. We can also use the hack to subset all the elements in the reverse order. So we use the double column and then -1. There will be an exercise for slicing and subsetting. The first part of the exercise will be specifically to dealing with subsetting string, but some of those slicing operations would come in helpful, right? So I illustrate this indexing and slicing on lists, but really some of that, a lot of that would be basically applicable to strings as well. It's just if you do the every second character of a string, it gets a little bit messy and harder to illustrate. But otherwise, all these things work equally well on a string. Sets, right? So sets contain, as I said, they only contain unique elements, and they don't have the order, right? So they're not ordered. They're ordered somehow in the memory, but as a high-level programming language, Python hides away from us this, the technicalities of where things are stored. We should not. It tells us that we should not, be addressing sets by their indices. What happens if we create a set with non-unique values? So, for example, we have the string apple twice. If we do it with curly braces to say this is a set, only unique element appears, right? So we only have apple. We don't have another apple here, as would have happened, for example, with a list or a tuple, right? Interestingly, sets can be compared. So this is again an interesting hack that can help you sometimes for some of the tasks, set Apple is basically a subset of an Apple O, of the set O, which contains Apple, right? So and we get our Boolean value of true back. As I said, sets are unordered. Again, they are stored somehow in some way on the actual hard drive physically, but this is completely hidden from us for the practical purposes of us being and Python users. Set object is not subscriptable. Some of the set methods in Python, this will work similarly in R. I mean, they would come as functions in R as opposed to being methods. And I believe symmetric difference is actually called XOR in R. Otherwise, they union, intersection, and difference would be similar across all of the programming languages that you might be familiar with. So for if we do the union, right? So both elements from one set, let's say A and set B, will be returned to us. If we do the intersection, only the elements that contain within both sets. So let's say within the both circles, the area here corresponding to the elements that contained within both sets. Exactly. If in database parlance, union would be a full join. Intersection. I believe union should be. Yes, I believe a union should be a full join, and intersection would be an inner join. Yeah, the difference only the elements that are contained within one, but not another, and then symmetric difference, also known as XOR function. So if you look it up, it's basically XOR function only gives you back the those elements that are contained within that are contained exclusively within one of the two sets. Example from I'm a political scientist by training, so some of the examples where sets come in political science are complicated diplomatic structures within Europe. So here it's a picture from Wikipedia, which also keeps it keeps getting modified. I think with the UK leaving the European Union, also never being part of Eurozone. Now it's here. I believe in the past few months, I think Russia is no more in the Council of Europe due to the war going on, as we all know. Some of those structures are pretty intense, but essentially all of this can be represented as a giant set, right? So for example, here we can create 3 sets: Nordic, EU, and Crohn's. I slightly simplified. So EU is certainly not just Denmark, Finland, and Sweden. I just didn't want to write all of the 27 EU member states. And then we can use all of this, all these methods using those methods. So right, so if we want to see what EU country, what of those EU countries in this set use euro as opposed to using Crohn's, we can subtract essentially, right, the Crohn set from the EU set. So it can be expressed also the infix operator on the 2 sets, EU minus Crohn's, and we get the set back Finland. We can do the difference, like we can take the Nordic as our starting set and then subtract, basically, right? Take the difference and subtract the countries that are in the EU. In particular, here it would be Denmark, Finland, and Sweden. And then we can add Liechtenstein, a set containing Liechtenstein and Switzerland to get to EFTA, right? To European Free Trade Agreement. Beyond the political science side of it, and one thing I wanted to illustrate here is the chaining of methods, right? So far we've seen we have an original object, and then we have some method applied to that object, dot difference, for example, EU, we can naturally just save all of the above, EFTA equals Nordic dot difference EU, and then proceed to it wouldn't be quite EFTA, it would be some temp object, and then proceed to merge that temp object with Liechtenstein and Switzerland. However, as we can also add chain another dot and proceed to applying another method directly. So if you are familiar with the tidyverse, for example, in piping, in piping operator, a lot of the same things, although might potentially less, they're not quite as readable as with the piping, could be achieved with pandas using the chaining of the methods applied to the data frame. So it's not quite exactly the equivalent, but I think it probably comes the closest to piping. Difference math. So we difference method should also include Iceland and Norway. Difference method did not exclude Iceland and Norway from Nordic just because they are not in the EU, right? So we don't have them. Well, they're not in the EU technically, and they're not in the EU set, right? So we excluded only the countries that are in the EU set from Nordic, and then we added Liechtenstein and Switzerland. So ordering is random. That's exactly the point. So there is there is no ordering guaranteed to the end user. So in practice, they kind of seem to be ordered alphabetically here, which often is the case, but we specifically cannot rely on that, right? So there is no, if we want to sort them in some way, we need to change the structure of the type of the object, right? So we need to go from let's say set. So we have a defined set. We can go to a list and then sort that list, right? So there is no the set bind itself is not designed to tell us anything about the order, basically. So that is part one. There is no particular reason other than they could be, but adding the diagram I showed you before naturally presupposes some operation of a setting, right? So this essentially what we see here is essentially a very sophisticated type Euler diagram, or if you might be familiar, right? So what I showed you before was basically the Venn diagram, familiar Venn diagrams. This is the more sophisticated Euler diagram technically, but this the natural representation for that Euler diagram would be with the sets. So I'd say if in choosing the representing this with some structure, I think the set would be a most like if you want to extract the information from this diagram, the set would be the most natural way of doing so. That's with a rather complicated structure, which I just didn't want to go through the entirety in emulating it here, right? So that's why I didn't have the EU with the actual fully fledged EU. EFTA in intersection, the intersection EFTA in Nordic gives us Iceland and Norway. Again, this can be achieved with the infix operator, such as and then Schengen, we can do the EFTA plus the EU, right? So the union also. So note that intersection is represented by an ampersand and sign, and union is represented by or pipe, right? And then we get we've got all of the countries here. Again, these are not all the countries in the Schengen, but these are the countries from sort of the toy example that I have. Let's move on and talk about dictionaries. Back on a few slides ago, I defined this dictionary with several keys: apple, banana, and watermelon, and several values associated with those keys: 150.0, 120, 3000. Unlike any of the types, any of the sequences that we looked at before, dictionaries are indexed by keys, right? So they're not ordered in any way, but they are defined. And then Apple, for example, if we have a dictionary and we want to extract the value associated with a specific key in this dictionary, again, we are referring to our subsetting operator, right? So we're using the square brackets and then Apple as our key here, rather than in integers, right? Again, as I showed you with the tuples, if we do that with the tuples, we get an error. Sorry, with the sets, right? So if we do the indexing with sets, we get an error. So we can do that. We can do the tuples, list, and strings. We cannot do that with either sets, set, and dictionaries. In two sets. Yeah. So if you do the question in the chat, sets only keep only unique values, right? So there is if the value if this is a union of two sets, we share the value, it only will appear once. Yes, thank you, Johnson, for addressing this. If we put a value of yes, but that's some slightly trickier. So the reason for that is that the keys in the dictionary are unique, right? So while the values are actually not guaranteed to be unique at all. So since key is the prime way of addressing a value in the dictionary, Python always knows that once you give it a key, it looks for a specific value, but the value can be the same value can be associated with many different keys. So you would need to basically iteratively go through all the values, and then extract those that are associated with this specific key, right? So it is slightly more involved. So it kind of depends on what the structure would be when you create your dictionary. However, dictionaries are mutable, just like lists and sets. So if you do if you added a new key, for example, strawberry did not exist here before, we can just create a new one. We can write d strawberry equals 12.0. And now it appears, we printed out the entirety of that dictionary D, and then it appears in here below. But conversion between non-scalar types, right? So some would say a tuple. Tuple can easily be converted into a list. If, for example, you, for some reason, have a tuple and you want it to actually be modifiable, so you want individual elements. Can keys? No. So keys cannot be repeated keys cannot be repeated in a dictionary. So they have to be unique. If the key already exists in a dictionary and you create a new one, and you create so let's say here, instead of strawberry, I would have said apple. The value for apple would have been overwritten with 12.0, right? So the apple here would be the apple would not appear twice. It just the value would be modified. So the keys have to be unique. Right. So conversion between different between non-scalar types. So we have a tuple. That's pretty straight. Some of this, just as with it's just with the scalar types, right? We discussed that some of the scalar types can be pretty intuitively represented by another, one by another. So if you have a Boolean true or false, you can just represent equally well by 1 and 0. It's harder to do or impossible without losing some information if you go from flotation point number to an integer. The same works for non-scalar types. Some of them can be converted with only minimal modifications, such as list, tuple and tail list, or vice versa. Some of them could be more complicated and more involved. So, for example, if you want to convert a dictionary into a list, naturally it would require some. It would require some losses, right? So you will need to take some losses when you walk from go from one to another. One thing I wanted to show you in particular. So let's say we have a list comprehension, which is really commonly used. If you're familiar with loops, this is since this is more of a data science dive. I won't go into the fully fledged functions and writing loops. Again, feel free to check the slides on control flow for the lectures I'm teaching here for the introduction to programming. The basics, right? The basics of looping or iteration. We go for go on one element to the sequence after another. And then we do something with this, right? So we pick one element out of a sequence, then we pick another element. We can just pick them, right? We just pick them and print them out, and do nothing with them. Or we can say, add one to each individual number that we have. This is in the fully fledged loop, which would write, across multiple lines of code. In with list comprehension, we can just do the same within one line of code, right? So X for X and T is literally just saying that we are going one element after another within the tuple. Since this is a list comprehension, so any iterable, any sequence that we can iterate over can be used within the list comprehension. But since this is list comprehension and the list comprehension is defined by the square brackets, we get a list back, right? So even though we iterated over a tuple, we get a list back because of the list comprehension. List comprehensions had very long history. They're one of the first comprehensions to iterate over individual elements within a sequence. These days, there are set comprehensions and there are dictionary comprehensions in newer versions of Python. I won't go into those. They have similar structure, but slightly different. As long as you are familiar with loops and iteration, that should be pretty straightforward to you. But the list comprehensions, as the oldest and sort of the most widely probably used feature of Python, is here to be mentioned. The general syntax, just over here, expression. Here I didn't do anything, but for example, I could have written x plus 1. X plus 1 would have been broken though on the second element, as you can imagine. In iterable, it can be a tuple, it can be a list, it can be anything else, which is it can be a string, and then we can have some tests if want. Here I didn't have any test. But for example, we can throw away if some number is less than less than 1, for example. Yeah, non-scalar conversion from dictionaries to lists. Yes. So there is, as I said, once you convert from one non-scalar type to another, you would naturally lose some information. There is no natural way of representing both keys and values within the same list. So one thing you can do is to basically iterate over over both keys and values, and sort of throw them in together within the same comprehension. I'll show. I can show it. Let me just make a note. Can show it maybe during the exercise time. But otherwise there is no list comprehension. So list comprehension is basically a way to write a loop or an iteration over each individual sequence, individual element in a sequence within a single line of code, right? Maybe the easiest, okay, I think it's maybe the time to, let's say we have so we have a list, we have a tuple. I'll just be writing in a random place within this exercise. Just don't. This is in no way related, right? So we can. So let's say we can do x plus 1 for x in t. And will give us back every. So here we get for each element in t, right? So each element in this tuple t, we add a 1 to it. And since this is a list comprehension, we get it back as a list. Now, if let's say tuple, it doesn't really matter as long as t or whatever object we have after in can be iterated over, right? So if, for example, it was if this was a list, let's say if we just keep it the same name, it would work equally well, right? So as long as this can be iterated over, we can do something with it, right? So if we say x plus 2. And let's say if x is more or equal to 1. Right, so I didn't have the test, any test in the original one, but if we do it with a test, we can do something like this, right? So we only add plus 2 to those elements, those axes in T that are greater or equal to 1. One thing also to say, I think, to mention, x is can be anything. It's just most often x is just a placeholder, right? As long as this is the same letter or the same expression, this works equally. So, for example, if you do I plus 2 for I, oops, if I is greater or equal than 1, this wouldn't work. Yeah, so it's a great question whether something is iterable or not. The general definition of whether something is an iterable or not is whether something has a iter method associated with it. So, oops. So that is the that is the actual technical definition of what it means to be an iterable. So there are iterables, like I cannot mention all the iterables because they can, anybody can create an iterable him or herself by implementing a function for an object, right? So for some object, if you create it. So in terms of the built-in structures, lists, tuples, and strings are iterable, so you can iterate over them. Sets, basically ordered structures are iterable by definition because they have the natural ordering. Sets and dictionaries technically would not be iterable by themselves. On the more like a technical note, it's kind of hard to define the full set of iterables that you can do it. But technically, as long as there is an iter function that knows how to give you a next element from a sequence, this is an iterable. Yeah, perfect. Thank you. Yes, despite it appearing at the end, that comparison is done in the beginning, right? So we first check, first I is checked for that. First, this condition is checked, and then this is applied. I would not right. I would not, 0 would not be affected, but it also is omitted because we only do and get back. So we don't need to do I plus 2, so I guess because we have, right. So if we do I plus, it can be used as a way of filtering, right? So if you use so if we want to filter out all the elements that are less than 1, or keep only the elements that are greater or equal than 1, we can just do I for I in T without action. Yes, so immutable does not mean unchangeable. Immutable means that individual elements cannot be replaced. Yes. So there, as with strings, right? So for example, I have this dishwasher string here, right? So I cannot do this. Oops. Oh, I guess it forgot what dishwasher is. Let's remind it. Yeah. Right. So we cannot do item individual item assignment, but we can do something like this, right? As I said, with an exclamation. Right. So you cannot change an individual elements. That means immutability. So individual, but you can add. You can, in general, they can indeed be changed. Let's so some of the conversions. So for example, with set conversion, here I just apply the function set as opposed to doing the curly braces. Only retains the unique values. Null value is just a Python null object. Can be used to, so it's more similar to an A in R than it is to null. Since you can have a list with 10 nulls, but you cannot do a vector with 10 nulls in R. However, do note that once we go into the data frame and the missing data, it's not quite an A. there is a like with indexing from 0, there is an entire discussion, which if you ask me, I can give you pointers on, what is the best way to represent missing data in arrays. But none is built in, and in its built in, it's most similar to array in R than it is to null. It is also a return value some functions. You can initialize it as a temporary variable. You can do something like this if you want to initialize a list of 10 values, and you don't know, for example, you don't know what those values would be. You don't even know what the type of those values would be eventually. You can just do nones. Yeah, none equals the weird comparisons can be made. One last thing, probably before we head for the exercise and the break, aliasing versus copying in R. So assignment. So as we started the discussion, binds the variable of a name, the left hand side of the equal sign to the object of certain type of the right hand side. But the same object can have different names. Oftentimes, the same object would be, the object would be just overwritten, when you reassign the name. So operations on the mutable types typically override the object if it gets modified, right? So if you write x equals 3 and then you write x equals 5, the object to which x refers to just got overwritten. For mutable types, the story is a little bit more complicated. It can create some hard to track problems, right? So we have, for example, a mutable type character string test. It's assigned to name x. We create another one. We can create it just y equals x, y equals test, x now. Then we reassign the original one. Reassign x. Now it's rest. Y is still test, right? So y was unmodified here. So this is for immutable types, right? So strings are mutable is that individual elements could not be modified, right? So the general, we can change them, but could not reassign a new value to the already existing element, right? How would it look like for mutable types? Let's look at the lists, the dictionary, for example. And the same works with lists. This example is just with dictionaries, but the same problem applies to a broader scale of mutable types. So we have dictionary D that we already looked at, the one where after we added strawberry in there, like creating our fruit salad. And then we create an alias here, right? So we create D1. Note that we think that we might have copied an object. We didn't do anything special here. It's just an assignment operator. But in practice, it's just an alias, as opposed to actually calling a method copy, which created an entirely new object which was bound to the name D2, right? So D1 and D still point to essentially the same object. So now we modify the underlying object D. So now instead of watermelon being 3000, we have it 500. The problem, as you can see, that D1 also got modified, even though we probably did not expect that to happen, right? So watermelon here is now 500, even though we actually didn't do anything with D1, right? We only did this modification, applied this modification to D. As opposed to D2, which we explicitly created a copy of, and now it has the original value for the watermelon equals 3000, right? So this is something to keep in mind for mutable types. that typically we would only it will only create an alias as opposed to a shallow copy, as opposed to an alias, as opposed to an actually copying an entire object. Well, practical value of it is a trade-off in terms of memory, right? So if especially if you think about not only necessarily big data, but the data that like barely squeezes on in RAM. If on every reassignment an entire data frame would have been copied, we would very soon run out of RAM necessarily, essentially. So the same here. Sometimes it might be practical because you even for the sake of renaming an object. So for example, you can explain the function of an object. The object was created for certain function, and then it outlived its function, and then you create an alias to make a more meaningful name for that object, right? You can think about a data frame which you modified there was some modification to the data frame, and you don't want to create a copy of the data frame. You don't care about the original data frame anymore, but you want to rename it just because it reflects better the nature of the new data frame. List of lists is often recommended as I'm not actually sure why list of lists is often recommended to by dictionary. I probably think it has to do something with efficiency, and it potentially has to do something with efficiency and in terms of retrieval by index. But I would need to see a specific example. One variable value to it's just assigning a different name to the same object. So aliasing is basically assigning well, you can think about it as a variable value, but it's basically a name for an object, right? So we have an object like 3, an integer 3, and we have a name x. In case of immutable types, it just gets it just gets copied. It's a small enough object, right? So the most immutable types would only hold so much space because they're so small, and then it would be automatically be copied. So it's basically another name to the same object for the same object. All right, let's see how we're doing time-wise. This is just a summary of built-in object types in Python. Yeah, basically what we discussed, and in terms of whether they're scalar, whether they're mutability. The three things to keep in mind about core built-in object types in Python is whether they're scalar, whether they're mutable, and whether they're ordered. Right. So we discussed the scalar. We discussed the mutability. Again, mutability is whether individual elements within the sequence can be replaced, and then whether they're ordered in a sense that whether we can refer to each element using some index. Let's probably skip the modules. I'll briefly talk about it in pandas when we talk about pandas. One last thing to mention before the exercise and a break is how to get help, right? So we get stuck. I was doing some last touches on the airplane, for example, and it's interesting experience always to program when you don't have access to the internet and Stack Overflow and you can Google anything. So sometimes we need access to some documentation that is just there, sits on our computer, ready to be read by us, basically. The two ways to do that. One way is to do question mark, and then the object. So for if it would be familiar for you from R, or we can explicitly call a function help if you want to know more about a specific method or a specific function, for example, right? So if we're interested in what the function as.join does, we can do help as.join. All the usual things, the quality documentation, GitHub. GitHub is a great source as well as Stack Overflow, but bearing in mind the thing about this Python 2 versus Python 3, or just looking up on a search engine works equally well. All right, I think we're broadly done with the again, this is definitely not like this is just scratching the surface of core Python objects. We didn't talk about methods. We didn't talk about functions, about control flow, etc. But this should give us enough foundation to make a dive into more data science things for the second part. Let's combine probably I hope nobody will mind if we combine the break, let's say 15 minutes break, and with a quick exercise. So you can find it here in the basics. The first part is literally just some things about the slicing and indexing, and then the other one is just to give you a bit of time to tinker with sets, and then also look sets and lists and set and some conversions. So there they should all be pretty intuitive. But yeah, maybe let's reconvene in about 15 minutes, and I'll quickly just go over how we can do this. Maybe I'll stop sharing for a moment. Hi, everybody. I hope you had a bit of time to rest or look at the exercise materials and practice a little bit of Python. Let's jump straight in and go over some of those, maybe all of those, if depending on how we go. Right. Maybe the slicing one is both could be trickier, but also probably more consequential for a lot of other things that we are going to be talking about. Right. So basically, we have this this long character string. We want to be able to extract some of the words or constituting phrases from it using just slicing operation. Let's start. The first one should be pretty straightforward, right? We really only need to specify where to stop, right? We know we can just start from the very beginning. We can just count 0, 1, 2, 3. We do need to go one more, right? So we can so if we do up to 3, it would only give us the first 3. It will stop at the last one. By stop basically means the stop actually itself is not included. The stop meaning so if we want to get the actual word dish out of it, we want something like this, right? We want to say 4, and then we can print it out. For wash, we need to specify. So right, it's it would be slightly more involved, right? We need to specify both the beginning and the end. So we have dishwasher, right? We want to start at W, right? W is right. We can just count 0, 1, 2, 3, 4, right? So if we do oops, dishwasher. All right, so we 4 will give us W, and then we'll need to specify all the way until we go 5, 6, 7, 7, but we need to as before, right? We need to go all the way to 8 to get H in here as well, right? So here exactly the same story, right? It's just the indices are different. So here, right, so we just need to change the indices from 4 to 8 to 7 to 9. What's the next one? So right, so is slightly anybody anyone got the saw out of dishwasher? So out of dishwasher, right, great, yes, perfect, right? So we our start is before, right? So the tricky part here is that the start is before the after the beginning, and then the stop is earlier, and then we go back, right? Perfect, right? So we have so, and for the reversed, right, we can just do the that will yeah -4 to -7 -1 would also work. Maybe slightly less intuitive, although it's kind of unclear which one. Like I'm not entirely sure that 6 to 3 to -1 with the step of -1 is more intuitive than -4 to minus. Yeah, I kind of legitimately say. But yeah, the same can be achieved with the. Oops. Oh, my Zoom is kind of slow. Wrap dishwasher, like -1. This will give us the reverse, right? So we just as we saw with the list, this one doesn't make any sense, but this gives us the reverse. Perfect, everybody. Good with the indexing and slicing. The second one is really pretty straightforward. I mean, it's mostly just typing, to be honest. I mean, it's mostly typing and knowing the flag, knowing the flags of the country, or clicking through. So I won't spend too much time here. Well, let's print it out though. Right, so that's pretty straightforward. The other one is also relatively straightforward, I believe. It's just to illustrate some conversion between back and forth. We have some list. I already typed it in. We have the Baltic. We convert it into set. We have Benelux. We also can convert into sect, and then we create a union. The only interesting part here really is the creation of is the chaining, right? So we can chain together Visegrad Union, Baltic Union, Benelux, and then we have Euro, right? So I just call it Euro again. It's not it's not a Eurozone. It actually literally isn't, because I think Poland and Hungary do not have do not use euros. The last one is maybe slightly more interesting. Let's quickly go through it. Right, so we have we can start by modifying the Visegrad, right? So we can, for example, since we already have it, right? So we have Visegrad. Let's just now convert it into a list. Let's make it a list. And then let's also sort that list so that we will ease our usage of that as a key, right? So we have Czech Republic, Hungary, Poland, Slovakia, right? So we just since they are originally unordered, we kind of need, they might potentially come out correctly even without explicitly sorting them. But in practice, we don't want to rely on those, right? The recording should be available after the after we end. So you should be able to just view it. Let's just create some capitals as well. Again, this is mostly just let's see, typing. Prague. Budapest. I really tried. Let me check how Warsaw, and Bratislava. So we capitals. So let's. I'll show you two things so first thing is the zip function. It's a really nifty function. Let's see. So here we can do zip Visegrad capitals. Now these days, I think it actually creates just an iterator. So I think we probably this just created an iterator. Let's unpack this iterator by making an entail list. What essentially it did, right? So it mapped the first element of one list to the first element of the other list, and then the second element of the first list to the second element of the second list, and third, etc., etc. Right? So it just basically mapped the elements sequentially between the two different lists, and they came in tuples, right? So they come in tuples. I mean the outside list over here is just because I use lists. So right, and if I use tuple, for example, it would have been tuple. But one thing we can do is as I said, there are other comprehensions. So we use list comprehension, for example, but one can do the same for a dictionary. So we can write key value for key value in zip capitals. Right. So this is a variation on the same. But once you see the syntax for list comprehensions, the other comprehensions should be relatively straightforward. So right. So here we just do key value pair for key comma value in this iterator, right? So the zip created this iterator where we basically have those pairs put together between one and another, right? So from the two different ones. So just to show you basically the list comprehension and and zip function. So zip function is something I have to say I use quite a lot in Python, and I do miss it quite a bit in R. So in R, you kind of have to resort to mappings. You have to do basically map or apply to get the same idea, right? So I mean, it depends on how you create it. Did you create a list in here? So if you created the list, that should so for the let's say dictionary. It's really weird. I mean, if I feel like if you create a list, if it's in square brackets, the ordering should be preserved. Like it should be exactly in the order in which you specified it here. So just make sure that they are in square brackets, like it's. Let me paste it in here. Was I saying? Yeah, wishing dict. I just didn't save it last time, so let's say wishing that is for that. That's very strange. I mean, well, okay, perfect. Yeah, no, it should be that. Yeah, bracket. If you did it with a curly braces, it would have created it, made it into a set, and then the set could potentially order things, even though we don't rely on them being ordered. But like, we cannot request, but it would do that. Capital of the country using yes. So. This one. And I can request, let's say, Poland, right? We get Warsaw, so I don't wish it, right? yeah, I think these are the only interesting lines of code. The rest was pretty straightforward. I mean, I did sort the list over here as well.
Sorry, there is a question on YouTube. How would you unsort the capitals list? Mine automatically sorted it when it shouldn't have.
Oh, but I think it's similar to the question we received in the Zoom. It's real. I think somebody really wrote it as a set. So I think somebody really wrote. Let me now go here. So if you did it as a set, if you did it, and so right, this is. This is list. If you, however, created a set with curly braces, oops, set, it would actually automatically sort it for you, right? So you really need to pay close attention to what is the type of brackets you're using, like braces, right? So if this is curly braces, then it's sorted for you. But if it's a list, it just, yeah, it should not be sorted unless you explicitly requested it. Share I don't think I can. Oh, I see. Okay. Yeah. Definitely. Let's see version. Okay, let's given the time constraints, let's assume that we are good on this part, and then we can move on to the next part, maybe more interesting for some of you, the actual one that involves more data analysis and data science applications. I'll start with just talking about the basic representation of tabular data in Python, pandas, and some basic data input and output, and then hopefully we'll get time to go through visualizations and some of the more descriptive stuff. Rectangular data, right? So rectangular data today, we probably most commonly see them as Excel spreadsheets or CSV files. You can trace the history back to punch cards if you're old enough. My grandfather was just working at a factory, but they used some of those punch cards there to process some of the for some of the machinery. They used the punch cards. He used a ton of them just as basically notebooks at home. So unfortunately I don't think we have any left. I really should have grabbed some of them. But if you've seen the punch cards, you already this is where the tabular data sort of comes from. Used in social sciences world, it was used to sync US Census data. These days, when we think about tabular data, when we think about rectangular data, we really mean this. And I really like this. This is not really Python. This I shamelessly borrowed from R for Data Science from Hadley Wickham's, but I think this encapsulates really well what is meant by rectangular data in data processing pipelines of today's world, right? So we have each variable in a column, we have each observation in a row, and each value is a cell. That's it, right? So it's really neat. It really summarizes really well what we mean by they call it tidy data. Again, it's a brand of some sort, but we really want, even if we're not within this sort of R or tidyverse paradigm, we really want our CSV files to look like this. I I'll show you the files later on, the ones I downloaded from Bureau for Transportation that I'll use an example. And they really were not that. They really produced CSV files that had some messy heading, and then they had some messy footnote at the end. Like they generally knew what they were doing, but they still somehow like produced the CSV files that were, even though generally pretty good, like it really didn't take long to post-process them, but they still had some weird stuff happening in that CSV file. So you really, if you are, the originator of the data, or if you're processing the data, really stick to this paradigm. I think it's describes it very well. Data in Python. So on the one hand, Python is extremely versatile, right? It can handle, a lot of data. It's pretty memory efficient. It's only really limited by how much RAM you have. However, the crux of it is that most functionality for dealing with data in Python is provided by external libraries, right? So in practice, you could think of some, list structures to represent tables, to represent spreadsheets. You can think of, some homemade solution to do this, and some of those basically internal solutions ended up being libraries like pandas, but there is nothing core to the language which represents even a matrix, let alone a data frame, right? So there is no even for matrices, you basically need to go to NumPy. Otherwise, there is no actual natural representation for core like mathematical and data analytical objects in Python. Pandas has become the de facto standard for working with tabular data in Python. So by standard, it's the de facto standard. It's not actually part of base R, base Python. Apologies again. So you need to install it separately. It's built upon and is used mostly together with some other libraries, in particular NumPy, the one that represents just array data types, the SciPy for linear algebra, and scikit-learn for machine learning. And again, some other stats models, for example, which provides a more R-like interface if you are interested in, running linear regression, for example, doing like two-way fixed effects or things like that. Scikit-learn does have linear regression, but it's much more machine learning focused. It's much more, caring about the predictions about your y-hats and less caring about, the actual estimates or, the error bounds and things like that. I skipped the modules in the previous slides, how we go about the modules. We import the modules using import keyword, right? So we use import pandas. We can just stop and say import pandas, in which case every time we refer to pandas, we would say import, we would say, pandas dot, and then some object contained within pandas, or we would use pandas, pandas.read CSV, for example, if we want to use the method for reading in the CSV file from outside, from somewhere on our hard drive. As allows us the next word, as allows us to avoid typing this full name, to avoid typing the full pandas every time we're referring to the module, which is really neat, which is really saves a lot of typing time. And PD, so like I do here, import pandas as PD is pretty much the standard way of importing pandas in your working environment. There are jokes on the internet, some like if you want to, scrap somebody's workflow, you can import pandas as like SciPy, and then import like SciPy as pandas and things like that. But I mean, unless you are actually trying to interfere with somebody's workflow, these are some of the conventions that most people working in this field are just adhering to, basically. Before we jump to data frames, we need to make one intermediate stop, which is series, which is only a one-dimensional array-like object, right? So with the data frame, we're talking about multiple dimensions. Well, usually we talk about 2 dimensions when we deal with tabular data. But series provides a first step towards it, right? So what is a series? A series, it kind of looks like what you would expect a vector look like, right? So it's just a one-dimensional array, it's just essentially a vector, right? You can create it using pd.series, and then you can just feed it a list here, for example, right? So we have a list, 150, 120, 3000 in square brackets. We put it inside the method dot series that comes from pandas. So here we're already using PD convention instead of writing the full pandas, and we call it SR1, right? Series 1. When I print it out, we see that it gives us the actual values that went in plus this thing on the left, right? So 0, 1, and 2. Which are the indices for each of those, right? So if before we had to know from just knowing Python that the first object has the index of 0, here indices already are given to us. One thing with indices, they are by default they would be produced like this, 0, 1, 2. But in practice, you can define your own indices, right? As long as the indices are unique values, you can have you can make them technically start from 1. It would be relatively, I guess, unintuitive broadly, but you can, you have some control. So you can think about indices and what has become mostly died out feature in base R. Row names, right? Row names that has been heavily criticized by a lot of people. In some way, you can think of indices on series in pandas, and analogously series in data frames as similar to row names. Slicing is similar to standard Python objects, right? So if you take the first element, we'll just write 0. And if you want to do, we can do slightly more sophisticated subsetting. So, for example, we can choose the elements of the series that are larger than 200 by writing something like SR1, and then in the square brackets we have our SR1 more than 200, right? And it does this subsetting of the series for us. Indexing a series, right? So one other way to think about series is as an ordered dictionary. That's why we sort of discussed dictionaries at such length in the previous hour, right? So, for example, you can have a dictionary that we already looked at with our fruits and weights associated with those fruits. And we can create a series out of the dictionary, and in which case the key of that dictionary becomes the index in our series, right? So now SR2, apple, banana, and watermelon are the keys in a sense that they are indices for that series, right? So it's still a one-dimensional. So in a float 64 is the actual type of that series, and so you can see here since the strings, the names went into the indices, our series, or you can think about as a type of a vector, right? In a sense, if you are in terms of R, you can think about as a type of a vector, and then indices here would be essentially it can essentially be seen also as a named vector, I guess, right? So if you a named vector with like names being slightly more sophisticated in that they are enforced, to be unique, etc., and sorted in some way, right? So, and float 64 in this case, right, indicates that these are all floating point numbers, since our actual string went into the index, right? The same happened in the previous slide, right? So here, since those are all floating points numbers, they are represented by this. So you can think about this just a float. We've seen floats before. This is just an internal pandas where it takes it from NumPy way of representing floats, right? However, right, once we move from dictionary to series, like that's the key about it being an ordered dictionary, in a sense that we are gaining this ability, gaining this feature of subsetting by order, right? This would be impossible, so we couldn't have written D0. Well, we could have written, but it naturally would result in just an error. So we also have that actual object. This is some data. When we talked about Python objects, right? We have the actual object, the value that is being stored, and then we have the name, right? So we have the this, and then we have some metadata associated with that. So in this case, index is this kind of metadata, is an attribute, right? It's an attribute of our series, which contains basically this index object, right? So where it says that this list essentially, right, is an index for the object named SR2. Right. So moving from series to data frames, where data frame is the principal way of analyzing data, right? In pandas and Python, and say with the same name would be in R. It's a rectangular table of data. Technically in Python, is not restricted to just 2 dimensions, but everything we'll be discussing here will be just the 2-dimensional data frames, right? So we won't talk about the data frames that can have the the 3rd or 4th dimension, time dimension, for example, which would be which would in R be represented as an array of a data frames, right? For example, I mean in R you cannot create a 3-dimensional data frame. So you would have an array of data frames. Again, here we will just start with the dictionary. Here, the dictionary is slightly more involved. So, right, instead of having just one single value, we will provide an entire list as a value to that for each key in that dictionary, right? And so here we have the keys for White and Berry, which will form the column names of the data frame, right? And then we have the actual values, the actual observations for in those columns, right? That here are stored as values, as lists that are values associated with each key, right? But otherwise, you still see that this is essentially a dictionary. We can directly go and feed this to pd.dataframe. Note that the data frame has to adhere to this camel casing, right? So camel casing, in a sense, the first word is the first letter of the word is uppercase, then it goes down, and then goes up again, the uppercase for the next word frame. So Python, I think there was a question earlier on about whether Python is case sensitive. Yes, Python is case sensitive, so you need to write explicitly data frame like this, and then you can go directly supply data as an argument to that method, right? So now we have our cute little data frame with three rows, 3 columns. It automatically created Python automatically created the indices 0, 1, 2 for it. Indexing in data frame, right? So we talked a lot about indexing and slicing in non-scalar objects in Python. Data frame has both row and column indices. So we have dataframe.lock method that provides that allows us to locate the by label, and then we have dataframe.ilock that provides a method to locating by index. So, example, if we want to have the first row, we can do df. Df is just is the name that we gave to our data frame, right? So we are here when we created, we assigned that data frame object to the name df, right? So now we can use this name df throughout the rest of the manipulations with this data frame. So here, for example, we have indexing in for indexing we have iloc, and then we just provided 0. It is a shortcut. Technically, we would have written 0 point to indicate that this is the rows, but this is one of the shortcuts available for indexing in data frames. And the same applies to the column, right? So we can do df.iloc. In case of the column, we actually need to specify that with the comma to indicate that this is a column and not we're referring to the column and not to the row. Also, so this syntax broadly should be similar to what, your experience in R, with the only difference that we specify column to say that we want all of the rows, right? So in R, you would just omit, you would just write comma 0. In Pandas and Python, you need to write column and then comma and then 0 for the first column. Can I combine question dictionaries and data frame with yeah, you can definitely, you can just keep appending and building together more post as a, you can like append rows as rows they'll probably have to be tuples, right? So I think you can append another data frame, but another dictionary, but the dictionary would basically binding a column. This is just a brief summary. Again, this no way I can go over all of the different ways of indexing in data frame. Just a brief overview beyond the difference between loc and iloc. One of the shortcuts is df-val, is column a sequence of columns. So for slicing, and here we just put the if you specify the name, for example, the value, we Pandas will give a column back. For location, if we are subsetting by rows, we can omit the comma and the column. If we're subsetting columns, we cannot. The same for iloc, right? So row subset of rows, and then the iloc is column, and we either specify in J if we want all of the rows. We write column here. iloc, ij, and some more niche, maybe single scalar value if you want by row, and column label or position you can do at or I at. The last one sounds more like a recording to me. So you would have a survey where you had like yes or no's, and then you would basically change yes to 1 and 0 to 2. So I think I think it's more like seems to me like more a transformation than the extending or like appending to the data frame. Subsetting in data frames, another right. So we talked a lot about slicing, about indexing and slicing. All of those, everything we discussed now applies to the data frame, right? So if we want to select the first 2 rows, we write column 2 if we don't have any commas or anything inside, pandas assumes that we are referring to rows and gives us rows back. Add a shortcut if we want just to even not specify the not write dialog. Obviously, some of those shortcuts are neat, but might be confusing. If some I would say probably, especially if you are coming, from our background, or especially if you are collaborating with people who might be not as deeply versed in all of the shortcuts available in pandas. I think probably the best idea would be actually to write full local for the subsetting. If we want to select the columns, for example, by name, we specify colon, comma, fruit berry, the columns that we want back. Again, there is a shortcut available with a double square brackets. Here it seems similar to subsetting lists in R, but don't be confused by it. This is a shortcut for still dealing with data frames, essentially. Columns and data frame, right? So we discussed the index object in series, right? So the same story that applied to the index object in series applies to the columns in the data frame, right? So if we want to retrieve the names of all the columns, we can write df.columns, and this gives us the attribute of this data frame of the df data frame. The index is also subsettable, right? So we can subset, we can specify the name of the first column, and again, the indexing starts from 0, so we write just 0 within our square brackets. A more involved one, and in the second exercise, if we'll get to it, there will be a question to select all the data which has some word in its name. So column names are still essentially strings, right? So all of the things that we discussed about regarding the string operations, the string methods, apply here as well, right? So one of those we didn't, and here we actually do need to say that we're treating it as a string. For example, one of them is starts with function, so it basically gives a method which tells us with a Boolean vector whether a given column name starts with letters with characters fr or not, right? So in back we get fruit's true, weight is false, and berry is false, right? So we have the a Boolean array returned back to us, which comes in handy if we want, for example, here it might not be as involved, just because we could have written fruit as a column name. But if you think about multiple, you can think about 100 questions, and then you want to select the questions that all have some variable name in them. You can do starts with, or you can use contains function that will be. You can try it in the exercise. Yeah, absolutely. Yeah, no problem. Absolutely. If you need to leave, I completely understand. And yeah, I think especially with the changes in with the changing in time, I completely understand that some of you might need to go, and hopefully you'll guys be able to come back to the recording and go over it. So absolutely feel free. Let's with the filtering in data frame. If we want to select the rows, for example, specific rows that adhere that contain or do not contain a certain value, or they meet some criteria. So for example, here we want to select all the rows that meet the criteria that in the berry column, the value is false. We can do that by basically nesting indexing, right? So we had first, we do first the indexing and the selection of the berry column. Then we check whether it is true or false. The value in that column is true or false, and then we use that value to subset as a subset for df. So we select rows, df square brackets, and then the Boolean array that resulted from this, from whatever is the inside the square brackets, right? Again, slightly more concise syntax. I'm not sure. It's just to show you that this can be achieved. I think generally, again, it's here with these things, it's probably best to be more explicit than when writing such code, I would say. As with the assignment, right? So when we started discussing the assignment in the previous part, the key is that we, unless we actually explicitly use the assignment operator, unless we explicitly bind the resulting value, resulting object to a new name, it is lost, right? So we just get this printed out, and then it never is retrieved again. If we want to actually explicitly save it, explicitly keep it, we can do that with the assignment operator. So here, for example, we create a new data frame using the assignment operator, which basically is a subset of the df data frame where weight variable, weight column is larger than 200. Right? So that's the basic of it. Variable transformation, slightly more involved, since we didn't talk much about the functions, and we didn't talk about this particular lambda functions. But the lambda function can be used to transform data with MapMap. Lambda function is not anything fancy. If you're familiar with functions, if you are in any other programming language, in R, for example, you're familiar with function that just takes some input and gives some output. Lambda function is just a function that we never gave a name to, right? It's just an unnamed function. So for example, in R, if you wrote something like function x and then some manipulation with that x without ever explicitly saving it as a function within your apply family function, for example, you would have used the same approach essentially, right? So here, instead of writing, function x as it would be in R, we can write lambda x, and then after colon we write what is actually our function does to the input x, right? So again, nothing sophisticated here. Again, the lambda function is just an unnamed function. There is nothing fancy about it. You need to sort of remember the syntax that you write lambda and then something after the column, but otherwise this is just an unnamed function, right? That unnamed function that the only thing it does, it uppercases everything in its input, right? And then we use a method map on our data frame, right? Where our data frame is basically a subset of the original data frame, where we're only modifying the variable fruit, right? So we should be. I'm aiming to wrap it up in about an hour 10 minutes, generally for today. So just there is a question in the chat box about how long the whole workshop was 4 hours. So we're getting close to that, but we have another hour to discuss data analysis. We can also, I said that the lambda functions for variable transformations, they are not they're essentially unnamed, they're anonymous, right? In practice, you can also just save it if you care. You can call it, transform. And for example, here I do capitalize instead of uppercase, and we get a different transformation of the fruit variable, of the fruit column, right? So we have apple, banana, watermelon, etc., etc. So this is so much for the dealing with the data frames in series. I want to digress a little bit now and talk about files and file objects and the connections to external files in Python. In contrast with like other core types, like file objects, they're created not the literal, but we we would just write a string within the quotation marks, or would write sat within the curly braces. Instead, we create file objects using open functions. So, right, it's pretty intuitive, right? There is nothing. We assign a name of the file object to some variable name on the left-hand side of the assignment operator. On the right-hand side, we have the open function, the file path, where a given file resides in our system, and the mode in which we want it to be opened, right? And I will talk a bit more about mode in just a moment, right? So that's the general syntax. So for data input and output, Python recognizes several different modes in which the file objects can be accessed, right? So we can just read it, which is the default. If we don't specify any other mode, it just reads, opens it for read only. And this mode is, since the read, it is denoted by letter R. Write for W, right, with double letter W corresponds to write, an object to a file, right? So if we open some connection to a file and then we write it out, we would open it with the mode W. It carries the risks though. So for example, you open an object, open a file, create a file connection, right? And you, but the file already exists, right? And then you created a new data frame, a new subsetting, and then you want to write it out to a file, but the file already exists. If you just specify W, it will overwrite the file without telling you anything about that the file exists. So that's why we have X for exclusively create, but fail if the file already exists, right? So if the file already exists, if we open the file connection with a X parameter, with an X mode, and we'll try to overwrite the file, it will fail if the file already exists. I think my Zoom just misbehaved for a second. Let me jump straight in back in, and I will punish my Zoom sometime after the end of this workshop for misbehaving at those important times. Okay. Okay, so we're at the data input and output, right? So I talking about exclusively create and fail if the file exists. And then if you want to append to a file, and the file, say, is already, we want to add additional lines to additional rows to the already existing object. We can open it with an A parameter, right? With an A mode. And then if you want to both read and write a file, we can do just R+ and do all of this together. So let's for this theory, just give you a concrete example of how what might be. Let's say I have some random test.txt file with some one line of something which resides in the temporary directory. So I create a file. I just call it f. Again, nothing specific about f. Again, just a name as with any other name that we assign to our file connection. Then we have temp, the file path, right, where it resides, and then I have w, because since I want to write to that file. Okay, yeah, I think the creating a files is a bit it's a bit trickier on the on Google Colab. I think they have a separate thing for file uploading. So I think you have to if you want to add data, you can just do that here. I'll show you how to read it indirectly from the URL. But broadly, yeah, I think that some of the file connections might be a bit weird. And I think, yeah, you probably don't like this. This is a path on the local machine where I created the slides, not the probably, yeah, you want to ditch this part on the on Google Colab. Yeah, thank you for that. We just write, if you want to write out, we just write fwrite. This is a test file, write a string of characters to it. It gives an output. The output is just the 20. 20 is just the number. Here is just the length of it, right? It's just the length of that specific string. And then, we have to flush the output buffers to disk and close the connection, so that nothing happens there. It's slightly involved, as you can imagine. This is like, to avoid keeping track of open file connections, we can use the with statement. So we can write something like with open the path, and then the mode, read mode as f. F is just the name that we give to it, and then we have for reading, and then we read it in text f.read. Text. This is a text file, right? This is the file that we created just on the previous slide. Seems pretty involved, right? So we probably don't want to be very much involved in all of this. Fortunately for us, Pandas provides high-level methods that take care of these file connections, right? So broadly, those two methods come in reading and writing out forms. So they have the same read underscore format and to underscore format name patterns. If you worked with any data before, you probably would be most familiar with comma-separated value files or CSV files. They are essentially the standard of interoperability. If you want to ship your files, data files between R and Python, CSV would be the best course of action, the best choice of the format. The benefit of CSV is naturally that you can also just open it in any text editor, say Visual Studio Code or Sublime, etc., and just read it in, right? It's human readable, as opposed to, which also comes at a cost that it's not very compressed, or it's not compressed at all, right? It provides, you can explicitly compress it, but otherwise it comes all at once uncompressed. There are some compressed formats. I won't go into the more details of more modern compressed, binary formats such as Parquet, for example, which take less space, but also have the disadvantage of they also have the advantage of interoperability, but they don't have the advantage of being able to read it in and human, in some human text editor. The general syntax, right? So if we read in a file in the pandas, we have our PD for pandas.read underscore format, and then the file path. And then on the left-hand side, we give the name of that data frame. If we want to write out, we have the name of the data frame, right? So we have the name of the data frame, dot, and then the method to CSV, and then the file path that we are writing it out. For this, since we this particular workshop has been quite a bit affected by flight delays caused by United Airlines, I decided to spend my delayed time yesterday on scraping some data about them from Bureau of Transportation. You can, if you go to that, it's a pretty good website. I realized when dealing with the flights data that actually most of the data is actually pretty hard to come by especially in terms of historical data. So if you ever have to deal with any flight delays or anything like that, I highly recommend thinking about where the ways of get the data about those delays beforehand, or like obtaining it on the spot, because most of the those websites that you would pop up in if you search for them, like Flight Radar or like Flight Aware, etc., they usually would charge you if the data is from before 7 days at most. That's what I found. If you want the actual historical data, this is actually a little bit trickier. And on the left-hand side is actually, on the left-hand side is just a funny YouTube video about United Airlines, so which clearly explains I'm not the only person who suffered from that, but the other person wrote a great what I think YouTube song showing and which definitely has much better outreach than the data I collected. So I'll use the data from the Bureau of Transportation, domestic departures from major US airports. It's also kind of harder to get for Europe, as I realized. So if anybody knows the good sources of getting historical airline data for Europe, I'll be very grateful. For reasons of the amount of data that it takes, I only kept it to between 1st of January and 31st of May 2022. So it's all very recent. This year, I think the end of May was the most recent that they provided, and then I just scraped the only major US airports, which accounted for the bulk of the data, but it also kind of kept to keep it manageable to what it was in the tens of thousands. The data is available on GitHub. So here I read it in with pd.readcsv. Data, and this is the path on my local machine. So if you want to read it in Kaggle, you can do two things. You can do add data here on the right-hand side, or another alternative, which I believe should work. I guess I should import pandas first. Import pandas as PD. Perfect. Yes, perfect. Yes, if you can read it in directly with the URL from GitHub. Yes, that's exactly what I wanted to show. So it should work. It should probably will take some time. Oh, on the. It will actually didn't take much time, but it all. Right, so it shows that there are I don't remember about 150,000 rows individual flights, and then 18 for 18 columns. Right, so yeah, basic data frame info, right? So I showed already you the shape, but right, we have the basic data dimensionality. I mentioned that we will be only restricting ourselves to 2-dimensional data for here in practice, as opposed to R, as I did say already. Pandas allows you to have multiple dimensions for your data. right? I won't delve deep into that functionality. Let's just assume that the number of dimensions here for the most data analysis task would be 2-dimensional. We can do that with an attribute and dim for the object that we write in. It's 2-dimensional, rows and columns. Size of each dimension, which is analogous to R's dim function. So it returns as a tuple, right? So we have the number of rows and the number of columns. So you see how the tuples would be used typically for the things that are more fixed. So we do know that tuple in terms of the shape of our data is the number of rows and the number of columns, right? So we have and given the data set, it's a fixed quantity, right? We don't want this to be randomly reassigned to something else, right? So I think this is a good example of why tuples might be sometimes preferred to lists, right? This is as an attribute of this data frame, this is a pretty fixed quantity, right? Total number of cells might be less informative. It's just the product of the number of rows and the number of columns, but it also is available as a size attribute. Some visual data inspection, the usual things. You start from the top. You look at the head of the data. Again, head would not be a function as you might be used to in our context. Head is a method associated with the data frame, right? So here we have first the name of the data frame, which we gave to the data set when we write it in, and then head as the method that applied, right? Otherwise, is the same top n and the equals 5 is the default. You can manipulate if you put n equals 1 here, for example, you will get only the very first row. This data is I also focused on the departures data, not on the arrivals data. I guess since this is domestic, probably they could be just fully joined. It will result in like 30 something columns. But so for the sake of simplicity, I just focused on the departures here, right? So we have the carrier code is all the same. So I only decided to look for mostly indicative reasons at United. And then the origin of the airport and the destination airport, and then all the usual things that you. Some of the interesting data that I've never actually seen before is you can have the delay split up by where the delay is actually coming from, which I'm not entirely sure how that is collected, but you can see the delay in the late arrival aircraft as opposed to the security, as opposed to navigation system and weather, etc., etc. The same with the tail, the head and tail, the usual functions that we start with. Reading in other non-CSV data files, so pandas can read in other files, not comma separated. In particular, the things that you might care most about, the data files, DTA, SPSS, and SAS files. It can, I believe it can read some Excel spreadsheets. I haven't investigated fully the functionality of the reading in of the Excel spreadsheets. Excel spreadsheets are always tricky because they have multiple sheets in them. So you usually would be able to read only the first sheet, or you would need to, actually, I guess the multi-sheet spreadsheets would probably be best represented as multi-dimensional data frames, right? So you'd have several data frames across several dimensions, but you can read in for all the examples on working with different data files in pandas here, and it's constantly updated because input output things that are changed quite a bit. For writing data out in pandas, that the main thing is syntax-wise is to note that we start with the name of the object. So, right, we have the data frame df.to CSV and then the path, as opposed to reading where we have pd.readcsv, right? So, and again, the pandas can write to Excel, so that's something that I've checked, and then you can write into Stata, and I think and CSV, and the probably provides reading it from other things, but I hope you won't be testing the functionality of reading it out into SPSS or SAS file. SAS probably works quite decently. SPSS, that's I'm not entirely sure. That's probably a pretty rare scenario. So for example, here I saved it to a CSV file which resides in my temporary directory. Some additional pandas material. The book is great, and the getting started tutorials are really good, as well as the pandas official documentation. So this is so much for the for the basic intro into pandas. Let's unless there are any immediate questions, let's move on to the last bit, which is the some data analysis, exploratory data analysis, and some principles of data visualization. All right, so the last topic I wanted to discuss with you is the exploratory data analysis and data visualization. Exploratory data analysis probably receives less attention these days, other than in the realm of data visualization, than things like causal inference and machine learning. But its importance should not be understated, as one of the fathers of contemporary statistics said, can never be the whole story, but if nothing else, can serve its foundation story as the first step towards other parts of data analysis, right? I mean, one should not succumb to the flow path where you throw in things into a machine learning model or some regression without first looking at the distribution of the data, checking what the range of the data, things like that. And the study's feasibility, scope, framing, they all depend on the results of the exploratory data analysis. I won't delve deep into the measurement scales. You probably, if you are coming from social science background or natural sciences background, it should all be relatively familiar to you. The nominal, the ordinal, the interval, ratio scales, going back all to the original paper by Stevens. The way typically we would represent measurement scales, so how do we map those theoretic measurement scales in pandas? So interval and ratio would typically be represented as some sort of numeric, right? So and then for nominal and ordinal, we would use the categorical type, right? So I don't have much of discussion about the dealing with categorical data more broadly, of working with categorical data as we would do with factors in R, for example. But if you follow that link, there is a pretty comprehensive user guide on dealing with the categorical data more explicitly. So the loading the data set, we import the pandas module, reading the data set with read underscore CSV method. Here I specify that I only want to get the very first top row, just to see whether things look the way they should. Summarizing numeric variables, right? So data frame methods. So if you are used with to R with its summary function, or to Stata with the describe function, you would the first thing to do is to get some sense of what the data looks like, what the variables are. Data frame methods and pandas can automatically handle missing data. So when we talked about none type, right? So we talked about none being the built-in data type in Python. And again, the discussion of why it is not used as the missing data in pandas is more than we have time for. But basically, the basic idea is that NaN is what NAs in R are in the data frames, right? So these are the values that represent missing data in the data frames in pandas, right? So if we do the describe method, which again is essentially analogous to any summary statistic function that you are used to in another programming language or another statistical package, we get the summary for the general summary for all of the quantitative variables, right? So one thing to note here, we only got the quantitative variables. All of the non-quantitative variables were ignored. I think it actually changed very recently in the previous versions of pandas. If you, for example, using a slightly older one, it used to be that there will be nonce all over for categorical variables, right? So it's only now here that they are completely omitted when we use the describe method. Some of those naturally are not very, should be actually treated as categorical. So, for example, you can see the flight number is in practice, since it's always just a number, blank rows. I think this one is not does not have any blank rows, I believe, but otherwise you should look at the is null is null function. So I think the general so this should broadly be used to determine whether or it's null, or I think it's I think it says null here. I wonder how help works in Kaggle. Let's see. Yeah, so that should have maybe the actual call should be omitted, and then you can for the is null, and then you can do the sum up, or you can determine which ones is null, and then you can do the exclusion based on which ones, just like as the filtering we did before. You can do the filtering with as null, and then with the feeding that Boolean array to subset, right? Some methods for summarizing numeric values. So, right, so we did the summary. We just here relied on the pandas to give us all of the information, all the summary statistics about those this data set. If we want specific values for specific columns, right? So what we can do is we subset a specific column. So for example, we're interested in delays, and we want to apply individual methods. We chain those methods just as we did before with other with other objects, right? We have the mean of the departure delay in minutes. It's 14. You can double check, that this corresponds to what describe function gave you, right? So this is this value. So we just replicating it separately using, if we want to just focus on specific value specifics. Interestingly, as I discovered, the median of the departure delays is actually 0. We'll later look at the actual histogram of the distribution in the exercise of how departure delays are distributed across how what the distribution is like. It's very there are some pretty intense. So as you can see here, just thinking quantitatively about the data, you can see that this is a right tail distribution. There are some really intense delays. There are some like 24-hour delays and things like that in the actual data. I think you can actually look at see it here. So if you have, for example, you have the mean and the maximum, and then I think this is about 1 day, I think, in minutes. And then the minimum, there are actual negative delays, interestingly. So something one can learn from looking at this data set. Then we can calculate, the standard deviation. One thing to say also, we don't have to rely on pandas for providing those functions, right? So those functions are essentially provided, they're built in with pandas, but we don't have to rely on those, right? We can, so for example, Python, like core Python, has a pretty basic, I have to say, statistics module, which just comes with a core distribution, right? So when you install Python, you just have access to statistics module, and it contains also standard deviation. Contains a range of other functions. Here I just show you for comparison that we can arrive to the same estimates using different approaches and not just rely on whatever is provided by Pandas. So for example, we can import statistics and do statistics standard stdef or standard deviation. And then here I also just showing that we don't have to subset using the name of the column, right? We can also locate the column by its index. So it might be less intuitive and it might not be necessary in most cases, but I think it's useful to see that we can achieve this with external tools. Or we can, at the end of the day, we can also write our own function that would handle that would calculate some statistics for an individual column in Pandas data frame. So far, we focused only on describing numerical variables, right? The ones that would be, either interval or ratio scale in the Stevens categorization. But we do have categorical variables as well. We would want to classify them in some way. So if you want to just do that through the core, broader describe functionality, we can add an argument include equals all, and it will have all of the variables present in the irrespective of whether they are categorical, numerical, or categorical. Some of them might not be very informative. Some of them could be. So, for example, for the origin airport, we see that the Denver airport has the most, and then the destination airport is Newark in New Jersey, has the highest frequency, right? This is the frequency associated with the most frequent category with the mode, and the same here. Some methods for summarizing categorical variables, as we've already seen, most for the most frequent value. Here I just did it for the flight number. For the count of unique value counts is a very useful function to keep in mind. So if you've been using a table function for any reason, for just calculating, the tabulation of an individual column or individual variable, or if you used it for cross tabulation, it is value counts essentially provide similar functionality where it can be used for tabulating a single variable, like here, and it can be also for the cross tabulation. We'll also use cross tab function, but for the single vector use of the table function in R, value counts provides with that, right? So basically here we see that Denver, the most for the origin airport has we have 32,245 flights departing from there in our data set, and then around 25,000 for New Jersey, and then 24,000 for, I believe it's Orlando, or maybe it's Chicago, O'Hara. I would not. I'm not actually sure. So, etc., right? What exactly we describe? So from describe function, we broadly get a sense of the measurement scale for each of the variables, right? So we can it's directly equivalent to describe and summary in Stata and R, where we get a broad, sort of a high level view of the data set. We get we get to see whether there are any nonsensical values, for example, for some of the variables for which we would not expect any, right? So there would potentially be some variables where for example, if you have a gender variable and it should only contain men and women, or even let's say it contains 5 categories, non-binary, etc., but you suddenly see some random -10 there as the most, the minimal value. You have some like 85 value for as the maximum, etc. You can see basically it's a high level of detecting irregularities with the data. I don't think you would quite be able to determine which are the variables the best for the machine learning. I think this is certainly not the case, but I think what you can provide is some variables that you probably would want either to explore more, or you would want to basically say that some of those variables might just basically be garbage and you want to ignore them for the sake of the analysis, or you want to have a deeper dive into understanding what happened and why these variables result in the values that should not be there. If we want to normalize for the value counts for our table data table analog, we can also use normalized true argument, which basically does what prop table does in R, right? So it basically normalizes by dividing this number by the sum of all of those, which in this case is just the number of rows, right? So the total number of those is just the number of rows. So it normalizes, and we can see that 21% of the departures in this data set happened from Denver, and then 17% happened from New Jersey, from Newark. Just a quick summary of some of the descriptive statistics methods that are available. I won't. I touched most of them. Some of them, you would naturally expect to exist: skewness, kurtosis, etc. A quick note on cross-tabulation. So I already said that value counts is basically analogous to use of table in R on a single variable. PD cross-tab is analogous to using table on 2 different variables. We want to internally in pandas a special case of pivot table. But we will just ignore that for the purposes of this workshop. It is great for discerning some associations between different categorical variables, right? So cross-tabulation is at the core of working with categorical data. Essentially, it's just nothing more than the computation of group frequencies. So if we do cross-tab in pandas, for example, we can do PD cross-tab, United 2022, origin airport and destination airport. So we have the full scale. This one might not be the most easy, the easiest to browse, right? We probably would restrict ourselves to only a handful of those. Maybe especially on the column side. So because here we have all of the domestic destinations within the US, but we get some counts to give to get a scale of whether for example, this one could be used to determine whether certain routes even exist or not, right? So we get from this cross tabulation, we can get a sense of all of the routes that are available for analysis. One other note to make: margins and crosstabs, right? So we want to normalize by either rows or columns. So for example, how many of the flights to Atlanta originated in JFK for United, it's 0, and for example 1.7 originated in Texas, and then 11%, 0.11 originated in Dallas Airport in DC. So right, we can do the same if we replace normalized columns with normalized rows. We can do the same, but the summation and the division happens across rows as opposed to across columns. Okay, the very last thing I wanted to talk to you about is data visualization. I wanted to show you one library and give you an intuition about a couple of others that are available in Python. And just presenting this as one of the potentially the best visualizations according to a good number of people, which dates back to the 19th century, which describes Napoleon's march on Moscow, which dates back itself all the way to the beginning of the 19th century. And it's mostly known due to work by Edward Tufte, whose book I highly recommend. Or it's very high level in terms of it doesn't teach you any programmatic skills, but it tells you a lot about what a good data visualization would look like. So in terms of inspiration and getting a sense of what is the best way of tackling data visualization task at hand, I would highly recommend looking at this. What about data visualization in Python now, right? So as we're dealing with data, Python has no built-in, base plotting functionality. If you used to R, where you have, the base plot, and then you have, lattice, and then you would use ggplot. These days, matplotlib has become one of the standard solutions. It's also used in combination with pandas to the point that some of the pandas built in plotting functionality is basically a wrapper around matplotlib, and other popular alternatives include Seaborn and Plot9. I would like to actually focus on the very last one, Plot9, especially given I think the number of people here who are coming from our background. I think Plot9 would be better received potentially. Plotly is a good example as well. Yeah, Plotly is more cross-platform, so I think if you used it in R, for example, it's a more cross-language one. So, but yeah, thank you for mentioning Plotly as well. But basically what Plot9 is, and I think that's the reason why I really wanted to talk about it, is basically ggplot for Python, right? So the Plot9 implements grammar graphics data visualization scheme, all according to the original work by Wilkinson. And on top of not just implements the grammar of graphics, it actually mimics the syntax of ggplot too, right? So and to the point that actually a lot of code can almost seamlessly be, and this is like almost like strange to see that you can basically copy paste ggplot to code to Plot9 and then essentially like run it. I mean, some of the arguments sometimes are off, and there is one trick about having the plus sign, but otherwise it works almost like a charm. You just take it and run it with it. A note on grammar graphics for those of you who haven't come across it before. It's a very powerful conceptualization of plotting, right? It's not actually like an engineering. It's not actually programmatic in any way. It's basically the idea of breaking graphs into multiple layers and then recombining those layers across multiple plots, reusing those the same layer, reusing the same underlying data, or reusing the same underlying scatter plot, and putting smooth lines on top of it. I cannot actually comment. There is a question in the chat about pie charts. I'm not very familiar with this module, so I don't think I would be able to comment on how suitable it is. The name seems like a pun on like I'd expect sort of pie charts out of it, or it's I guess a pie charts for Python, but I've never encountered. I don't think I would be able to say anything about it. Structure of ggplot calls in plot9, right? So the plot9 basically has the same structure, other than, as you can see, it has for syntactic reasons in Python. You cannot just have random pluses and then not terminate them. So you need to have the backslash in order to get to the next line. Otherwise, all the same. ggplot data equals whatever the data is. Geom function, the same. All the geoms that you might be familiar with. The mapping with aesthetics. If the mappings are reused across geometric objects, so for example, scatterplot and a line, you can add several geoms just like you would be used to in ggplot2. How do we create a plot in plot9? So far we've seen import pandas or import statistics or import pandas as PD, which is the suggested way of importing external modules. Plot9 relies on the possibility of importing methods from modules directly without being able to, without needing to refer to plot9, without needing to write, plot9.ggplot, which allows the neat integration with all the geoms. So it uses what generally is a relatively risky syntax. So when you do from some module import star, it means that all of the objects contained within this module will be imported directly into your current working session without needing to, and you would not need to actually reference, write this PD or plot9 in the beginning and then do dot and then do the method, for example. Which means, right, if you have some name clashes, if you have the names used in the external library, which you are importing, and you have the same names in your current session, the objects that you are importing from the external library would override whatever you are having in your current working session. So, right, it can create some understandable problems, which is why this is generally not very recommended syntax. But plot9 specifically uses it because you in an attempt to mimic ggplot2, you kind of need to do that within Python. Otherwise, you can just do as usually, import plot9 as pl, for example, and do like pl.ggplot, pl.geombar, etc., etc. So, for example, if you wanted to do a bar chart of origin airports, this syntax should, if you are familiar with the ggplot, it should be directly familiar to you. If not, the first part of it is where we specify what the data are we using. So, right, we're using the data frame United_2022. Then we have the plus to add another layer, right, as per grammar of graphics. And here we're adding the layer of the bar chart layer, right? The only thing that we really need to specify for the bar chart layer, since it does the calculation automatically of the, it does these counts automatically for us, is what do we want to show on the X, right? So it's essentially it shows us the value counts, right? So those value counts that looked at a few slides before in visual form, right? It presents this value counts in visual form, right? And it also did the sorting. So here you can also see that it did the alphabetic sorting of the airport EATA codes. AES stands for aesthetics. And here we just specify what our X is, and then the calculation happens automatically. So I save it as an origin_plot, and then I printed out here. Let's compare. So, before, so that I spend some time, telling you how this might compare to base pandas. So you can do similar in base pandas. The thing is with the base pandas that you need to pre-calculate the height of those bars, right? You need to pre-calculate how many times did this particular code occur in the data, right? So we cannot just specify that, we want to have a bar chart of the origin airport. We would need to actually specify, we would actually need to pre-calculate. So we can, which can be done by like grouping by. If you're familiar with the group by in dplyr, that's exactly the same. But here, as I said, instead of piping, we're using the chaining syntax. So we do group by origin airport, and then we calculate the size. So this one just creates the counts for each individual code, and then we can do plot of that data frame. This is a data frame, right? It's just a data frame, much smaller data frame, which essentially is value similar to value counts data frame. And then we do plot kind bar as an argument, and then we have something like this, which is not bad. But the idea to we do need to pre-calculate this thing every time we plot it. The pandas built-in functionality is relatively limited, and it is essentially built on top of matplotlib. So it's essentially multiple wrappers on top of matplotlib. So for example, as you can see, that graphically they're somewhat similar. We need to for matplotlib, we need to do this importing, import matplotlib .pyplot as plt, and then we do plt.bar. We are still using again the same data frame that we created on the previous slide, the grouped data frame with the pre-calculated heights of the bars. So we're using its index for the access, right? So the index is the same index attribute with the same index object that we've looked at before, all the way to panda series, and then the height is are the values, right? So the values for that of that data frame of that series, right? So it's not actually I stand corrected, since this is basically this would be in R. It would have been a data frame with two variables, with two columns, right? In Python, this is essentially a series where origin airport now is the index. I believe there is a question. I think somebody raised hand. Yeah.
Yeah, I have a question. So.
Yeah. Please.
Yeah. So before for the height, you have to, because I'm saying United 2022 origin group, so you have to do the group by function for it, and then before you apply it for the pandas. Is that correct?
Yeah. So yes, because you need to calculate how many per which you do the aggregation, basically by which variable you do the aggregation, essentially. Yeah.
Okay, so thank you very much.
Yeah, it would be essentially in R, it would be group by, and then n would be the size, essentially, with the group by summaries n equals n for the size. But yeah, okay. You have to do that.
Okay, thank you.
You're welcome. Yeah, think about it. Maybe it's possible to do it with value counts. I haven't quite tried, but maybe you can pre-calculate with value counts by it would still require the pre-calculation of value counts, right? So with the doing with the table. So it's either one. Either way, it would be required to pre-calculate the heights, essentially. A few notes on predefined ggplots in plot 9, just to show that some other things would work as well. So we can do origin plot pretty, and here again the grammar of graphics comes in. So we saved the original plot as origin plot, and then now we're just adding additional layers. We're modifying the labels. For example, we are modifying the label for the y-axis. And then I just like black and white theme. So in the last line, I'm just adding the black and white theme. As you can see, it's now doesn't have the gray background as in the original, and then I just print it out here in the last line. Delay. It will be quite involved. Like, yeah, we can. We'll need to calculate average daily average daily delay. Let me maybe wrap it up, and then I can spend the last 5-10 minutes remaining just looking at looking at this. Just to wrap it up, the geometric objects, if you are familiar with ggplot, it's all there. If not, geom_bar, geom_call, the box plot, histogram, the scatter plot for point, with point, line, map, smooth, violin, everything is there. Writing plots out, so you can do the usual, PDF, PNG, PS, depending on what the journal requires. Origin plot pretty .save as a method, and then the output path. So I already recommended Tufty's book. Kieran Healy's book is focused on R, but since it's focused on all of the examples are from ggplot2, I can highly recommend it if you're going to use plot 9, for example, with Python. I can definitely recommend it in as a very hands-on approach to teaching data visualization in ggplot2, but it's compatible basically with plot 9. And that's really about it in terms of the lecture type materials I prepare. I still have another exercise depending on how we are doing on time. Maybe if, let's say, give it like 5 minutes, if you guys want to quickly look at the exercise, which is available. Oops. Import notebook. Exercises to pandas. Yeah, if we spend maybe 5 minutes, and then we can quickly look at some of those. I think especially the last one. The last one is probably the most fun one. It's just the plotting of histogram of departure delays, which, I mean, you can think of it as fun or otherwise, I guess, depending on which side of you are. I guess it's fun to analyze after you're done, but might Oh, I think I didn't. I think the problem with this one is like, yeah. The problem with this one, I did not. I should have. Yes, that's. It should be view raw, and then. Yes, that's the actual. That's the actual one. Let me fix it here. So yeah, if you follow that actual that link, it should be view raw instead of just this, because otherwise it just basically tries to read this as a CSV file instead of just the CSV file. So that's my mistake here. So if you replace this with this, that should work. Yeah, so that's now it should be good. And let me. Yeah, I feel like I should really get get the things. Somebody did ask me about, I think, the average average daily time, average delay time. Yeah, okay, average delay time. Yes. Yeah, so this can be done like this. Maybe I should just share the public. So I did add, it's not ggplot though, but I did it, I did it with just the base the pandas. So this is the origin airport by average delay time per by flight. Okay, last all of those should be really pretty straightforward. Thank you. Yeah, no, I'm glad to see so many people from our background. Yeah. Just a quick yeah, let's do the quick walkthrough. Pilot 99 little 9. I think that just didn't work. Well, yes, this is our 100 to there's a question. Columns 1 to 5. All right, so for the columns we just need to specify colon and then what the columns we want. Oh, this seems like a wow, this is like this is a tough one. I have a question about the career trajectory. I'm not entirely sure. I'm very equipped. I mean, I worked in data science briefly after a master's degree in social research methods myself. I think when I did my master's, there were very few data science degrees, and there were far and few in between. So I still think that no matter which degree you do, I mean, as long as it is data and like computation heavy, and it should work out. I mean, broadly speaking, I mean, although the only skills that are were rarely addressed in academic programs are things like SQL, for example. I mean, it's very rarely used in academia vis-a-vis being used kind of everywhere in the industry. They're very specific. I think I think maybe Olga or others would be more equipped on answering about PhD on data science and Gemini. To be honest, I don't think I'm sure there are, but I just I'm not very versed in academia in Germany. I think there must be degrees. Maybe Hertie is doing something. I like that's yeah, something to ask. Okay. Masters in data science. Yeah, I mean, broadly speaking, I think without unless you really want an academic yeah, we are like kind of all kind of renders. I mean, I have a PhD in social research methods. So I think we're all just pretending to know what we're doing. Oops.
Sorry, Tom, can I really quick just ask can you post a link for this exercise, because you just posted the link for the old exercise, and someone on YouTube just asking, I want to like reshare the link.
Oh, the one for that notebook. For that notebook.
Yeah.
Oh, maybe it didn't. Oh, okay. Public. Well, I did that. Is it? Let's see. Is it? Yes. Oops. This is a really long chat. Okay, where we going? Oh, yeah, it's weird. Okay, I did copy. Oh, I know what it is. Okay. I think because I imported in the. Okay, so it's the same link, but if you click here on 2, wait, no, I think it's not a pause. Wait. Okay, it's version 1 of 2. So if I actually just randomly imported into the same thing. So if you just go to version 2, it's yeah. So if you switch to version 2, then it's literally the same, just different version. Version 2 for pandas. Yeah, I should have really just kept a different one. What is it? Contains airport strings. And then we can use that to substitute. United 2022. Okay. And then we can just copy paste that in here. So this is how we would go about, right? So we looked at starts with, but we can also use the string method contains with an airport, and then we do the origin and destination airport here. And this is just we saved the columns as a separate object, right? So this is just the column names basically. Okay, and then the last here I have another one with the average delay, and then the only other one is this is the histogram for This is the histogram for the departure delay. So let's quickly do histogram delay. Delay plot. Histogram minutes. So I think this is a basic. So this would be our basic. I mean, you can see that, there are like a lot of things happening. So one thing we can do is to remove some of the outliers. So let's say, one thing to do, I would say, is probably to remove some of the outliers. Let's say we don't really see anything above, 500. So we can do actually, we can probably do departure less than 100. This will be an array, and then we Boolean array, and then we can do this inside to use it as subsetting to subset, right? And then I think that will provide, let's say, 500. So this will be the one where we only have the flights that were delayed by less by 500 meters, so that it will ease our plotting. So we did we do have slightly fewer rows, right? We have 154,575, and now we have 154,379. So we lost around 100 observations. Depending on maybe sensitive, maybe it's not as good to just throw outliers, but in a grand scheme of this data set, this is less than 0.5% of the data. So we can just go ahead and do the ggplot. Let's do \geom histogram. And here will be the, right, so our aesthetics, yes, x equals departure delay minutes plus, let's just do black and white theme. So this is much better, right? So we can sort of slightly zoomed in. We still don't get much above 200, but we generally get a sense of the distribution. It's right-tailed. There are only the spike. Would be good to investigate that spike below zero, how much it drives down the median for zero. But broadly, this gives us a pretty fair impression of the data. I think this is about it. Unless there are any further questions, we perhaps could stop here. And given also the time that we're at now.
Yeah, just lots of thank yous. Thank yous on YouTube. Thank yous in the Zoom chat.
Thank you very much. No, this has been really great. Yeah, thank you.
Thank you so much, Tom, for such an amazing workshop. And I learned a lot. I hopefully like our audience also learned a lot. And yes, as I mentioned before, the recordings and all the materials are going to be available at the summer school webpage after the workshop. So stay tuned. And also just a quick reminder that we're continuing with the workshop series tomorrow with the calculus class. So if you are interested in more mathematical backgrounds that might be necessary for data science or some aspects of data science, please tune in. It is at 10 a.m. tomorrow, Berlin time. Yes, but I'm thanking Tom once again.
Thank you for inviting me. Thank you, Olga. Thank you, Hui.